Imagine, for a quiet moment, standing on the edge of the galactic dark, looking not at what we expect to see, but at what should not exist. The universe, we tell ourselves, is a clockwork of gravity and ice, where every cosmic wanderer obeys the celestial choreography of the sun. But in late November, the air felt sharp and dry with a new, subtle tension, a feeling that a ghost from an impossibly deep past was passing through the ballroom of our solar system. The factual context is a chilling one. On November 20th, 2025, amateur astronomers captured an image that defied the known laws of cometary physics, an astonishing X pattern extending for 1 million kilometers in either direction. This was not the expected gentle sweep of a solar wind-blown tail, but a tight, columnar geometry, 2 narrow jets shooting sideways, perpendicular to everything we understand about how a sun-heated ice ball should behave. The subtle paradox is this: if the object, designated 3I Atlas, is just a natural comet, its measured rotation of 16.16 hours should have smeared those jets into wide, chaotic spirals, like a spinning garden sprinkler. Yet, the jets were straight, perfectly aligned over a distance more than twice that from Earth to the Moon, moving at an impossible speed of 500 meters per second for 22 days without changing direction. What if, then, the esteemed Dr. Avi Loeb is correct, and these are not the trails of sublimating ice, but the vapor trails of smaller, independent mini-objects released by the main body near its closest approach to the sun? This possibility echoes an ancient, mythic theme that a visitor from a far-off land has come not to see, but to send. It shifts our existential reflection from the beauty of a natural anomaly to the profound question of intentionality, making us realize that our most sophisticated scientific instruments may now be observing the consequences of a design, not just a cosmic accident. Close your eyes, settle deeply into the quiet dark, and consider this. Where are you listening from tonight? And what time is it there? As we gaze upon this object that may be a window into the deep past, or perhaps a reflection of an intelligence that is still out there. The X pattern is real. The mystery is unfolding. We begin our quiet journey into the nature of this interstellar riddle. The journey into the quiet tension of 3I Atlas begins with an image, a photograph captured by the patient, steady gaze of amateur astronomers in late November. You picture the final result: 2100-second exposures stacked into a single, sharp portrait of the interstellar visitor. There, radiating from the central, blurred nucleus of the comet, is a pattern that feels geometrically absolute: a 4-pointed star, an X etched across the cosmic dark. It is this X, this symbol of intersection and departure, that has become the focus of a global, quiet debate between cautious consensus and audacious curiosity. The first anomaly of this segment, the X pattern geometry, is profoundly visual: 4 distinct directions of material ejection, where cometary physics dictates there should only be 1 or 2, always aligned generally toward or away from the sun. We, as observers, must grapple with the fundamental mechanism of a comet. Picture a gigantic, dirty snowball, kilometers in size, that has traveled for billions of years through the cold vacuum of space. When it finally swoops into the warmth of our sun, the ices of water, carbon dioxide, and carbon monoxide on its surface sublimate, they turn directly from solid to gas. This gas expands, carrying dust with it, creating a pressure, a natural thrust that forms the beautiful, flowing tails we see. This natural process, however, should only produce jets aligned with the direction of solar heating. Yet the dominant, troubling features in the November image are two narrow jets extending for approximately 1 million kilometers, perpendicular to the axis, connecting the Sun and the comet. This leads us to the second, deeper anomaly, the lack of rotational smearing. We know from earlier observations in July and August that 3I Atlas has a rotational period of 16.16 hours. Think of that garden sprinkler on a lawn, sending out a stream of water. If the sprinkler is spinning, the water does not form a straight column. It forms arcs, smeared across the lawn in a spiral pattern. Over the 22 days it took for the ejected material to travel 1 million kilometers a distance, requiring a speed of 500 meters per second. Relative to the nucleus, the comet would have completed approximately 45 full rotations. That immense rotation should have resulted in a smeared, diffuse, spiral jet, not the tightly collimated, perfectly straight beams that the November image revealed. The physics of an ice ball spinning and sublimating simply cannot explain a 1 million kilometer straight line. The third anomaly, the velocity and persistence of ejection, reinforces the mystery. For the trails to stretch out 1 million kilometers in 22 days, the material, or the objects that created the trail, must have been moving at 500 meters per second. While this speed is only slightly faster than the maximum expected outgassing velocity of 400 meters per second, the key lies in the persistence. An explosive outburst, a natural event where trapped volatiles suddenly escape, can launch material quickly. But those fragments of ice, the natural explanation, should sublimate rapidly as they travel, losing mass, tumbling, and quickly becoming chaotic and unrecognizable as distinct objects. Yet, here we have evidence of straight, persistent, highly organized trails after 22 days. This suggests a material with a high degree of structural integrity, or, quite simply, objects maintaining their own course and speed with a precision that ice cannot achieve. This confluence of impossible geometries leads us to the core mystery, to the mythic link Dr. Avi Loeb has dared to articulate. Are these trails the vaporized wake of mini-objects released by the main body? He proposed 3 possibilities for the straight jets. They are a remarkable, natural phenomenon, requiring a complete revision of cometary physics. They are the evaporated trails of natural fragments ejected in a sudden, explosive event, or they are produced by technological thrusters that preserve the object's global orientation for navigation. The most intriguing aspect of the technological hypothesis is that it offers the most elegant explanation for the collimation. If these mini-objects are probes, small spacecraft, released by a larger mothership, they would have their own independent propulsion and attitude control systems. They would not be bound by the rotation of the parent body. They could maintain perfectly straight, independent trajectories, which would then be traced by the dust and gas they release as they fly through the solar system. This is not science fiction, you realize, but standard operating procedure for our own space programs. A mothercraft, like Cassini, releasing smaller probes, like Huygens, to study different targets simultaneously. The great question becomes one of purpose, echoing the mythic search for the artifact. If these mini-objects exist, why were they released sideways, perpendicular to the solar axis? Was this an intentional deployment to observe a specific region, or simply the result of a crack or fault line on the main body oriented in that direction? No one knows yet, but the very existence of such a high degree of geometrical organization compels us to look beyond the idea of a simple, tumbling space rock. The next pivotal moment in this unfolding story is December 19th, 2025. The Day 3 I-Atlas makes its closest approach to Earth at a distance of 269 million kilometers. If the mini-objects, which departed on or around October 29th, 2025, have been traveling at a steady 500 meters per second, they will have separated from the main body by a massive distance of 2.2 million kilometers. This is a distance still close enough in cosmic terms to be associated with 3 I-Atlas, but crucially, far enough to be detectable as separate, discrete objects. If our most powerful telescopes, Hubble and the James Webb Space Telescope, are pointed to the right place, the quiet call from Dr. Loeb and others is for dedicated observing time, not just to look at the comet's hazy coma, but to scan the empty space around it, to look for the tiny, fast-moving dots that would confirm the existence of these mini-objects. If we find them, the ultimate test will be their trajectory. Natural fragments will tumble and spread out chaotically, their paths deviating quickly due to asymmetric outgassing. Technological probes, however, will maintain a stable trajectory, demonstrating course corrections that defy Newtonian gravity alone. This test, this acid test of the hypothesis, rests on the ability of the astronomical community to overcome its natural resistance to extraordinary claims and dedicate the necessary resources. For now, as the X pattern fades into the deeper blue, we must remember that the question is no longer if something broke off, but what broke off, and how it managed to travel in such impossibly straight lines. The story, like the straight jets, has only just begun to extend into the unknown. The existence of the X pattern is a stunning visual question mark, but it is merely the 12th entry in a growing ledger of cosmic strangeness. To truly appreciate the mystery of 3 I-Atlas, we must zoom out from the immediate photograph and survey the full catalogue of 12 anomalies, compiled by the rigorous methodology of Dr. Avi Loeb. Each point, taken alone, might be explained as a statistical fluke, a quirk of nature, but when stacked one upon the other, they create a picture of an object that is either the weirdest natural comet ever observed, or a phenomenon requiring an entirely new category of explanation. Our quiet reflection begins with anomaly number 1, the ecliptic alignment and retrograde motion. 3 I-Atlas is orbiting the Sun in a retrograde direction, opposite to all the planets, which is normal for an interstellar visitor that can arrive from any direction. What is profoundly unusual is that its orbital plane is aligned to within 5 degrees of the ecliptic plane, the flat disk containing Earth, Mars, and all the major planets. For a randomly arriving object, the probability of this alignment is a mere 0.2%, or 1 in 500. If you were designing a reconnaissance mission, seeking to gather data on the greatest number of planets in a single, fast pass, you would deliberately aim for this plane. The universe is not required to be so convenient. Anomaly number 2 is a physical defiance, the persistent sunward anti-tail. Most comets exhibit an anti-tail only as an optical illusion, a perspective effect caused by large dust particles lagging behind in the orbit. But for 3I Atlas, geometry confirms that the sunward jet is real material, flowing directly toward the sun. This material is being pushed against the solar wind, the relentless stream of charged particles flowing outward from the sun at hundreds of kilometers per second. To achieve this, the material must either be extremely large, like sand grains 1 million times more massive than typical dust, or the outflow velocity must be high enough to overcome the solar wind's pressure, requiring an enormous, sustained energy input beyond passive solar heating. The anti-tail has persisted for months, a continuous stream defying the fundamental physics of the solar environment. Anomaly number 3 is a statistical impossibility stack relating to size and speed. 3I Atlas is estimated to be roughly 1 million times more massive than the first interstellar visitor, 1I Oumuamua, and 1,000 times more massive than the second, 2I Borisov. Simultaneously, it is moving faster than both of them. The probability of finding an object that is both unusually large and unusually fast is less than 0.1%. The galaxy is vast, and highly improbable events occur. But when you combine this unlikelihood with the precise trajectory of the ecliptic alignment, the quiet questions begin to multiply. Anomaly number 4 is the fine-tuning of arrival timing and geometry. 3I Atlas arrived in the inner solar system at exactly the right moment to pass close to Mars, Venus, and Jupiter, while being entirely unobservable from Earth during its closest approach to the Sun, or perihelion. It was closest to Mars on October 3rd, 2025, close enough for the Mars Reconnaissance Orbiter to capture images. It will pass near Jupiter in March of 2026. If you were planning a reconnaissance mission, a grand tour of the inner solar system, this is precisely the highly efficient trajectory you would choose. The probability of this triple planet alignment happening by chance is an extraordinarily small 0.005%, or 1 in 20,000. Dr. Loeb reminds us that a probability this small does not prove anything, but the pattern of improbability itself is what warrants the closer look. Anomaly number 5. The early activity occurred far from the Sun. 3I Atlas was observed to be outgassing and forming a coma when it was 6.4 astronomical units from the Sun, near Jupiter's orbit. At this distance, sunlight is typically too weak to sublimate the water ice that dominates most comets. This activity requires either a composition of more volatile ices, like carbon monoxide or carbon dioxide, or an internal heat source. While these volatiles are known, the amount of activity this early was more than expected for a natural object. Anomaly number 6 is the lack of fragmentation. Comets are loosely bound rubble piles that commonly break apart under the thermal and tidal stresses near the Sun. Yet, despite its enormous mass loss, which Dr. Loeb initially calculated could be as high as 50 billion tons per month near perihelion, and despite a closest approach of only 1.4 astronomical units from the Sun, the nucleus remained intact. Images taken in November showed a single body with no evidence of breakup, suggesting an extraordinary structural strength or a highly non-typical internal composition. Anomaly number 7 concerns the brightness curve. As 3I Atlas approached the Sun, it brightened much more steeply than the standard power law for comets would predict, with an exponent of -3.9 instead of the usual -2 to -3. Stranger still, after passing its closest point to the Sun, the brightening curve flattened the object, continued to get brighter, even as it moved away from the Sun, the opposite of what is expected. This implies continued, or even increased, activity post-perihelion, a behavior that challenges our models of passive solar heating. Anomaly number 8 is the low dust-to-gas ratio. Spectroscopic observations revealed a coma, rich in gas volatiles like carbon dioxide and water, but comparatively poor in dust. Gas-rich comets, you might reflect, are inherently less predictable and more prone to dramatic outgassing events, a trait that fits the overall bizarre behavior of this visitor. Anomaly number 9 is the perplexing nickel detection. Some observations have reported the presence of atomic nickel in the gas plume, a metal not typically found in abundance in comets. The detection of nickel, especially with an unusually high nickel-to-iron ratio, could suggest a different formation history for this interstellar object. However, in the context of Dr. Loeb's hypothesis, the detection of metallic elements might also be a spectral hint of industrially produced nickel alloys, a subtle techno-signature hiding within the icy vapor. Anomaly number 10, the non-gravitational acceleration, is a key piece of dynamic evidence. The object's trajectory deviated measurably from a purely gravitational path near the Sun. While this is normal for comets, the magnitude and direction of the required net thrust derived from the multiple, complex jets that appeared suggests that far more mass was ejected near perihelion than is typical for a comet that remains intact. This acceleration, or lack thereof, is the ultimate measure of the net force acting on the object. Anomaly number 11 is the anti-tail persistence. We return to the sunward flow. The anti-tail has remained visible and prominent for months, a sustained flow that is difficult to account for with the models of natural fragmentation. To push material continuously against the solar wind for this length of time requires either an extreme, sustained outflow of massive particles or a mechanism that we do not fully grasp. And finally, anomaly number 12, which opened our story, the unsmeared orientation of the jets. The latest images show jets, including the sideways X pattern, that are perfectly straight and tightly collimated over 1 million kilometers, a formation impossible to reconcile with the 16-hour rotation period of the nucleus. The geometric precision suggests an active force, a guiding hand, or the straight-line trajectory of independently moving subcomponents. The cumulative probability of all 12 of these anomalies occurring by chance is astronomically small. Dr. Loeb, the cosmic philosopher, is not asserting the artificial hypothesis as fact, but simply pointing to the data, saying, the conventional explanation is insufficient. The universe is telling us that our model of normal is incomplete, and we must not exclude any possibility, even the most unconventional one, without rigorous investigation. As you drift with this knowledge, consider the vastness of the interstellar void from which this object came, traveling for billions of years. If it is natural, it is a treasure chest of new physics. If it is technological, it is the most profound discovery in human history. The subtle tension, then, is the realization that the simplest explanation, that it is just a comet, requires us to accept a pile of improbabilities that strain belief. We must keep our focus on the quiet insistence of the data as we move into the deeper historical echoes this anomaly awakens. Our contemplation now shifts from the immediate riddle of 3I Atlas to the historical context of its arrival, echoing two profound silences that have defined our cosmic curiosity for generations. This interstellar visitor is only the third confirmed object of its kind. Its predecessors, 1I Oumuamua and 2I Borisov, set a stage of profound ambiguity, but the current object has amplified the quiet tension to a chorus of anomalies. The first profound silence belongs to 1I Oumuamua, the Hawaiian name meaning a messenger from afar arriving first. Discovered in October 2017, Oumuamua left our solar system almost as quickly as it arrived, a long, cigar-shaped body that passed without a visible coma or tail. The ultimate, defining mystery of Oumuamua was its non-gravitational acceleration. It was speeding up as it moved away from the sun, but without the comet-like ejection of gas that should have provided the thrust. To account for this, the required amount of gas was simply not seen, leading Dr. Loeb to famously speculate that the only way to achieve that level of thrust without visible outgassing was if the object was a naturally thin, light, reflective structure, a light sail pushed by the subtle pressure of sunlight alone. We missed the chance for high-resolution images and detailed spectroscopy, and so Oumuamua remains an unresolved, frustrating question mark, a missed opportunity for definitive proof. The second interstellar visitor, 2I Borisov, discovered in 2019, offered a soothing reassurance. It looked and behaved exactly like a normal, active comet, with a clear coma and tail, confirming that interstellar space does indeed produce objects we can understand. But 3I Atlas, the third visitor, shattered this easy comfort, starting out normally, then becoming progressively stranger with every passing week. It is the anomaly that swallowed the rule, the exception that now forces the revision of the entire model. The second profound silence is the great silence itself, the puzzling absence of evidence for extraterrestrial civilizations, often summarized by the Fermi paradox. If the universe is teeming with life, why do we not see or hear any signs of it? The search for extraterrestrial intelligence, or SETI, typically listens for powerful, deliberate radio beacons from distant stars. The arrival of 3I Atlas offered a unique, nearby target for a more direct search for techno-signatures. In early November, the Meerkat radio telescope in South Africa, one of the world's most sensitive arrays, conducted a search for radio transmissions from 3I Atlas. It scanned a broad frequency range, listening for a signal as faint as what a cell phone might emit. The result was the second silence. No radio transmission was detected. This non-detection, however, is not a definitive refutation. It simply means the object is not transmitting in that specific frequency range at that power level. An advanced civilization would likely not use radio for interstellar communication, as the signal disperses rapidly. Lasers, focused into tight, non-dispersing beams, are far more efficient. The problem with searching for laser signals, known as optical SETI, is that you must be directly in the beam's path, which is highly improbable. Furthermore, Dr. Loeb suggests that a technological object would likely be a stealth probe. A reconnaissance mission does not announce its presence. It would be designed for minimal radio and infrared emissions, storing its data passively and only transmitting when safely far from the target. The absence of evidence, in this case, is entirely consistent with the hypothesis of a highly advanced, covert technological object. The third mythic echo is an unsettling coincidence: the alignment with the wow signal. Dr. Loeb has noted that the direction from which 3I Atlas entered our solar system is coincident to within 9 degrees of the origin point of the famous wow signal, a highly unusual radio pulse detected by the Big Ear radio telescope in Ohio in 1977. The likelihood of this directional coincidence being random is low, a mere 0.6%. While such a signal might not have traveled unimpeded for the decades since its detection, the proximity is another improbable thread woven into the fabric of this mystery, another statistical argument against pure randomness. You, the quiet observer, are left with a central realization about the scientific process. Scientists are naturally conservative. The burden of proof for an extraordinary claim that 3I Atlas is artificial is enormous. To be wrong about an alien probe is to risk ridicule and reputation. Thus, the default position of institutions like the National Aeronautics and Space Administration is, and must be, extreme caution, and the conventional explanation: it looks and behaves like a comet. All evidence points to it being a comet, but Dr. Loeb's philosophy is one of inquisitive humility. The way to maintain scientific credibility is not to ignore anomalies, it is to investigate them rigorously. The ultimate failure is not being wrong, but failing to look when the data suggests we should. The next segment will dive into the most profound and unsettling of the anomalies, the fine-tuned trajectory, which suggests a purpose beyond physics, a deliberate rendezvous with the largest planet in our solar system. The clock is ticking toward December 19th, and the time for caution is quickly fading into the past. We must look now, for the ghost of Oumuamua reminds us that if we do not, the answers will be gone forever. The quiet accumulation of the 12 anomalies shifts our perception, moving from a random, icy visitor to an object whose trajectory exhibits a bizarre, almost intentional, cosmic fine-tuning. This fine-tuning, anomaly number 4 in Dr. Loeb's catalogue, speaks not just of an improbable path, but of a route optimized for reconnaissance, an itinerary suggesting a purpose. Picture the vast, swirling architecture of our solar system. Imagine the planets as celestial pearls strung along the almost flat, two-dimensional fabric of the ecliptic plane. A random visitor from interstellar space should cut through this plane at a random, steep angle. Yet, 3I Atlas came in at a tilt of only 5 degrees to the ecliptic, a mere 0.2% probability. This alignment, however, is only the beginning of the uncanny convenience. The object's arrival time was precisely choreographed to bring it within tens of millions of kilometers of 3 major planets: Mars, Venus, and Jupiter. On October 3rd, 2025, it passed by Mars, close enough for the orbiters and even the Perseverance rover on the surface to capture images. In early November, it passed Venus. And finally, on March 16th, 2026, it will pass Jupiter at a distance of about 54 million kilometers. For a single random unpowered object, the probability of hitting this planetary trifecta is extraordinarily low, 0.005%, or one chance in 20,000. You realize that this is the kind of efficient, multi-target trajectory that human mission planners spend years calculating for the sake of conserving fuel. But the Jupiter rendezvous, the final waypoint in this deep space itinerary, holds the most profound implications. Here, the non-gravitational acceleration, the small, inexplicable thrust detected around the object's closest approach to the Sun, plays a newly discovered, crucial role. Dr. Loeb noticed that if one accounts for this non-gravitational push, the forecasted distance of 3I Atlas to Jupiter on March 16th, 2026, aligns almost perfectly with Jupiter's Hill radius. The Hill radius, you should imagine, is the edge of Jupiter's gravitational sovereignty, the boundary where its gravity is strong enough to keep objects in orbit around it, without them being stolen away by the much larger pull of the Sun. It is the perfect, energetically efficient place of equilibrium, a location where a spacecraft could use minimal fuel for station keeping. The non-gravitational acceleration, this small, strange push that defied natural cometary explanations, appears to have introduced a precise, finely tuned course, correction of exactly the magnitude needed to bring the object's trajectory to the value of Jupiter's Hill radius. The object would have missed this critical boundary otherwise. This discovery, which Dr. Loeb has flagged as a major anomaly, suggests a deliberate action, a precision maneuver that is hard to attribute to the chaotic venting of sublimating ice. It is the difference between a falling leaf hitting a general area and a guided drone landing precisely on a dime. The profound question this maneuver raises is one of the Jupiter seed. Why would an interstellar visitor make such a precise, fuel-efficient rendezvous with Jupiter's gravitational edge? The hypothesis, which is as cinematic as it is scientific, is that the object, if it is a mothership, is preparing to seed the giant planet with technological devices, perhaps releasing them as artificial satellites into the energetically stable Lagrange points along the Hill radius. If this is true, then 3I Atlas is not just a passing rock. It is a deployer, a celestial gardener planting tiny technological sentinels around the most massive planet in our solar system. This echoes the great cultural myths of exploration, reminiscent of the monolith in Arthur C. Clarke's story, which guided an ancient object toward Jupiter. Jupiter, after all, is a world of immense scientific interest, a miniature solar system with its own moons that harbor subsurface oceans and the potential for life. If an extraterrestrial intelligence is curious about our solar system, the study of Jupiter and its moons would be a top priority. If this hypothesis is correct, then the mini-objects suggested by the X pattern are more than just evaporated fragments. They are technological subcomponents, small, fast-moving probes that were released near the Sun to observe the inner planets and are now executing independent trajectories, some of which may be destined for Jupiter. The timing of the X pattern's appearance after the object passed Mars, as it headed toward Jupiter, becomes even more suspicious. The ultimate verification of this speculation lies in future observations. We must use the Juno spacecraft, already in orbit around Jupiter, or any future human-made orbiters, to look for new, tiny, unexpected objects orbiting the giant planet after 3I Atlas passes by in March 2026. Finding technological satellites that we did not launch would imply, quite simply, that Jupiter is of interest to an extraterrestrial civilization. Where are you listening from tonight? As we contemplate this object, this interstellar messenger that seems to have a fixed and calculated destination, the emotional curve of the scientific process bends here, from mere observation to the contemplation of intent. The universe is not required to be a random place, and the idea that the seemingly innocuous non-gravitational push was, in fact, a targeted maneuver is a profound and humbling thought. The data, however quietly, demands that we ask the question, what is the meaning of a trajectory that is too perfect? The answer, if it exists, is still moving, heading for its rendezvous with the great gas giant. The implications for the rest of our quiet journey are now entirely reframed by this one, small, finely tuned correction. The narrative thread of 3I Atlas is not only woven with cosmic anomalies, but also with a decidedly human one. The great silence of the government shutdown, which coincided with the most crucial phase of the object's journey. This convergence of astronomical significance and political dysfunction created a vacuum of information that, fairly or not, fueled the deepest public suspicions of a deliberate cover-up. The American government shutdown began on October 1st, 2025. You should place yourself in that moment. This interstellar object, the third ever found, was just days away from its closest approach to Mars and its closest approach to the Sun, or perihelion. This was precisely the time when the object was expected to be most active, most revealing, and when every telescope and spacecraft should have been gathering maximum data. Instead, the public flow of information from the National Aeronautics and Space Administration, or NASA, slowed to a trickle. The official explanation, of course, was purely bureaucratic. Non-essential personnel were furloughed, prohibited from processing data, writing press releases, or responding to media inquiries. The spacecraft continued to record data the deep space network kept functioning, but the crucial human element, the ability to analyze and communicate real-time findings, went dark. But the timing was suspiciously perfect, feeding the sense that something was being deliberately withheld. The cost of this 41-day silence, Dr. Loeb argued, was immense in terms of lost scientific opportunity. The optimal window for high-resolution spectroscopy and imaging was centered on the perihelion passage in late October. Consider the fate of the images captured by the Mars Reconnaissance Orbiter's high-resolution imaging science experiment camera. On October 2nd, 2025, the camera captured the closest views any NASA asset would get of 3I Atlas, from a distance of 19 million miles, or 30 million kilometers. The images were of critical importance, capturing the elusive X pattern and the distinct directions of material flow around the object's coma. Yet, this crucial evidence was not released to the public until November 19th, 48 days later. If NASA had released the high-resolution imaging science experiment image immediately, the global scientific community would have seen the X pattern on October 3rd. This would have provided 4 precious weeks to organize follow-up observations, retarget the Hubble and James Webb space telescopes, and capture data while the comet was at its brightest and most active. Instead, by the time the image became public, the optimal window had closed, and 3I Atlas was already moving away from the Sun, becoming dimmer and harder to analyze. The situation was exacerbated by the contrasting transparency of the European Space Agency, or ESA. The European Trace Gas Orbiter at Mars captured images on October 3rd, and those images, along with an analysis of the object's non-gravitational acceleration, were released quickly, without delay. By October 22nd, while NASA was silent, ESA was refining the object's trajectory, measuring the slight but real deviation from a purely gravitational path. The silence created a perfect information vacuum. The public, starved of official data, turned to unofficial sources. Wild claims of course corrections, acceleration toward Earth, and even the detection of radio signals spread unchecked on social media. Dr. Loeb's high-profile appearance on the Joe Rogan Experience podcast in early November, where he laid out the anomalies and criticized the delay, only amplified the controversy. You, the curious listener, should not necessarily leap to the conclusion of a conspiracy, but you should acknowledge the consequences of the bureaucratic failure. The fact is, the government shutdown cost us 41 days of potential, high-value observations during the critical window. It delayed the release of data, it prevented the real-time targeting of instruments, and it fostered an environment of public distrust. This is the human reflection in the cosmic mirror. Our political dysfunction, an entirely earthbound problem, may have cost us the definitive answer to the most important scientific question of our time. The time for definitive proof, the time to prove whether the jets are natural or artificial, was when the object was closest to the Sun, at its most active. Now, as it moves away, the opportunity is diminished. What we are left with are questions of missing data. What did the Mars atmosphere and volatile Evolution spacecraft's particle detectors record during the days around perihelion? What did the Solar and Heliospheric Observatory see when 3I Atlas passed through its field of view? This data may be sitting, unprocessed, in a queue, not hidden by intent, but buried by the sheer volume of information and the limited number of people available to analyze it. The truth will, eventually, come out, as data cannot be suppressed forever. But the quiet, uncomfortable lesson of the shutdown is that even in the face of an interstellar mystery, our own human failures of governance and communication can be the most effective barrier to discovery. The Great Silence was not imposed by an extraterrestrial intelligence seeking stealth, but by our own inability to keep the lights on when we needed them most. Let us return now to a single stubborn piece of physical evidence. Anomaly number 2, the sunward antitail. This is the feature that particularly vexes physicists, as it represents a persistent, visible defiance of the most fundamental force in the immediate solar environment, the solar wind. You must first understand the anatomy of a normal comet. When an icy body approaches the Sun, the resulting gas and dust are pushed away by 2 distinct forces. The gas is pushed away by the solar wind, a stream of high-speed, charged particles. The small, light dust particles are pushed by the solar radiation pressure, the subtle force of light itself. Both forces push material away from the Sun, creating the familiar, graceful tails that always point outward. The anti-tail of normal comets is a well-understood optical illusion, a mere trick of perspective. You see it when you look at the comet from a specific angle, making the large, heavy dust particles that lag behind in the comet's orbit appear to point toward the sun, even though they are still traveling perpendicular to the sun's direction. Once astronomers account for the viewing geometry, the illusion vanishes, resolving the feature into a normal dust trail. This physics has been understood for over a century, but the sunward jet of 3I Atlas is different. It does not resolve. Dr. Loeb and his colleagues have performed the careful geometric calculations, confirming that the jet is real material, flowing actively toward the sun. The physics, therefore, demands an explanation for this seemingly impossible feat. The simplest natural explanation is that the jet is composed of extremely large dust particles. To push through the constant outward pressure of the solar wind, the particles must have enough mass, enough inertia, that the solar wind has a negligible effect on them. Calculations suggest the particles would need an effective radius of about 100 micrometers, roughly the size of a grain of sand, and 1,000,000 times more massive than typical cometary dust. These massive particles, once launched, would continue moving sunward until the force of the solar wind, relentless over distance, finally slowed them down. The jet of 3I Atlas appears to terminate at about 1,000,000 kilometers from the nucleus, a distance consistent with where these heavy particles would finally be stopped by the solar wind pressure. This explanation, while plausible, introduces a new problem: the energy budget. How is 3I Atlas ejecting sand-sized grains at high velocity? Normal outgassing can lift small dust particles, but to launch 100 micrometer particles at 500 meters per second requires intense, sudden pressure, the signature of explosive events. Comets can have outbursts, but 3I Atlas has shown a persistent sunward flow since July, a continuous or near-continuous ejection lasting for 5 months. Dr. Loeb calculated that to sustain the observed anti-tail, the comet would need to be losing mass at a rate of about 50 billion tons per month. This number is staggering, and if sustained, would cause the comet to lose 1% of its total estimated mass every month, a rate that is simply not sustainable for a natural comet that remains intact. This paradox, massive, persistent mass loss without full disintegration, forces us to consider whether the mass loss rate is lower or whether the source of the expulsion is non-natural. If the mass loss rate is lower, the only way to generate the visible anti-tail is if the outflow velocity is much higher. If the gas velocity is several kilometers per second, instead of the expected 400 meters per second, the mass loss rate drops to a more sustainable 10 billion tons per month. But a gas velocity of several kilometers per second is a techno-signature. Chemical rockets produce exhaust velocities of 3 to 5 kilometers per second. Ion thrusters produce 10 to 50 kilometers per second. Measuring the velocity via high-resolution spectroscopy, the Doppler shift of the gas's spectral lines is the diagnostic test that will either confirm the natural model or reveal the artificial one. A third, more speculative natural possibility is that the anti-tail is not dust, but ionized gas flowing along the sun's magnetic field lines. If 3I Atlas is releasing material that is already electrically charged, that plasma could follow the curved magnetic field lines back toward the sun. This, however, would require the comet to have an unusually strong magnetic interaction or an active process generating electrical currents, which natural comets do not typically do. This path inevitably leads to the same uncomfortable question. For an object to display this level of highly organized, energetic, and sustained activity, it requires a powerful internal energy source beyond passive solar heating. The mythic implication is that the comet is actively fighting the sun, maintaining a sunward stance against the relentless pressure of the solar wind. It is an act of determined will, not a passive response to heat. You may settle your mind on the idea that every anomaly can be explained naturally, but each explanation requires 3I Atlas to be unusual in a highly specific way. For the sunward jet to exist, the comet must be either ejecting massive sand grains continuously for months, or be powered by a highly energetic internal source, or somehow interacting with the solar magnetic field in a way that defies all previous cometary models. The search for the truth, you realize, is not about finding what is absolutely impossible, but finding what is so exquisitely improbable that it suggests a pattern. The persistent sunward jet is one of the most compelling pieces of that puzzle, a constant, quiet reminder that something unusual is pushing back against the cosmic current. We must now turn our attention to the human search for the mini-objects, the deliberate hunt for the evidence of the X pattern's reality. The existence of the X pattern, those straight, narrow jets extending 1 million kilometers perpendicular to the sun, has pivoted the central question from one of physics to one of detection. Did 3I Atlas release something near perihelion? And if so, where are those mini-objects now? The hunt is on, not for the vapor trails, which are merely the consequence, but for the discrete objects, the potential fragments or probes that created those astonishingly straight lines. Let us imagine the two leading hypotheses for the mini-objects. The natural explanation states that near its closest approach to the Sun, or perihelion, the main nucleus partially fragmented. Internal pressure from super-volatile ices, such as nitrogen or methane, could have built up beneath the outer crust of water ice, leading to a sudden, explosive, outgassing event. This outburst would have violently ejected large chunks of ice and rock, which then began to sublimate as they traveled, their vaporized trails creating the observed jets. The challenge for this hypothesis is the columnation. Natural fragments, once ejected, would tumble, outgas asymmetrically, and quickly spread out into a chaotic, diffuse cloud. For the trails to remain so straight, the explosion would have needed to be highly directional, perhaps along a specific structural weakness, and the resulting fragments would have to be either perfectly shaped or somehow non-tumbling, both improbable scenarios. The technological explanation posits that the main body is a larger mothership spacecraft that deliberately release smaller, independent probes for reconnaissance. In this case, the mini-objects are self-powered and self-guided. Their active propulsion systems, small thrusters or attitude control jets, would allow them to maintain a stable, straight trajectory and their global orientation, regardless of the rotation of the parent body. The jets we see would be the exhaust from these thrusters, or the evaporated trails of the object's icy mantles, which may have accumulated during the long interstellar journey. The fact that the jets are perpendicular to the Sun-comet axis is explained simply as an intentional deployment angle for a specific targeting objective. The key to distinguishing between these two profound possibilities lies in obtaining two distinct sets of data: velocity and trajectory. First, velocity measurement. This is the most direct test. Natural sublimation has a maximum velocity of approximately 400 meters per second, which is the speed of sound in the gas at a few hundred degrees. If the gas in the jets is measured via high-resolution spectroscopy, the Doppler shift of the spectral lines to be moving faster than 400 meters per second, say at 1 or 2 kilometers per second, then the power source is not passive solar heating. Exhaust from a chemical rocket would be 3 to 5 kilometers per second. An ion thruster, 10 to 50 kilometers per second. A high-speed jet is a non-ambiguous, direct technosignature. Second, tracking the objects. The ultimate proof rests on finding the mini-objects themselves. We know that by December 19th, 2025, the day of closest approach to Earth, the mini-objects will have traveled 2.2 million kilometers from the main body. Dr. Loeb is calling for a concerted, global campaign to point the Hubble and James Webb space telescopes, as well as large ground-based observatories with adaptive optics, at the volume of space immediately surrounding 3I Atlas. The telescopes must search for faint, discrete objects in a wide-field survey, mapping the region within a few million kilometers of the main nucleus. The presence of separate, solid bodies with a structural integrity beyond that of a fragile rubble pile would be a strong hint, but the most convincing proof would be to track their trajectories over time. Natural fragments will follow chaotic, spreading paths. Technological probes would maintain a stable course, or even exhibit subtle, measurable course corrections and targeting maneuvers. The challenge is entirely institutional. Telescope time is precious, and Dr. Loeb is meeting resistance from the scientific community, which views the artificial hypothesis as a low-probability bet and a waste of resources. The quiet urgency is that the optimal window for these high-resolution, high-sensitivity observations is right now. After the December 19th closest approach, 3I Atlas will move away, the jets will weaken, and the faint mini-objects will become too dim to resolve. The mythic undertone of this segment is the notion of the test. The universe has delivered the evidence, and now humanity is being tested on its willingness to look. Dr. Loeb, the scientist who embodies this spirit, argues that the potential payoff, the discovery of an extraterrestrial technological relic, is too high to ignore for the sake of reputation or caution. The true cost is not the money spent on telescope time, but the lost opportunity to know the truth. As you reflect on this celestial hunt, you should keep your attention fixed on the possibility that the X pattern is not a trick of the light, but a map, a trail of breadcrumbs leading to the most profound of all human discoveries. The next few weeks, as the object makes its closest pass, are the last chance to collect the evidence that will resolve the question of the mini-objects and determine whether we are alone in this grand, silent theatre. Just as the drama of 3I Atlas reached its peak, a new actor quietly appeared on the cosmic stage, adding an uncanny layer of coincidence to the mystery. The discovery of C 2025 V1, a second fast-moving object reported just days after 3I Atlas passed perihelion. This raises the unsettling possibility of a pattern, a quiet intrusion by more than one visitor at the same time. The new object, V1, was discovered in early November by Gennady Borisov, the same astronomer who found the previous interstellar comet. Its initial data showed a highly inclined orbit and an orbital eccentricity of 1.95, a value greater than 1, which typically indicates a hyperbolic, unbound trajectory, meaning the object is not a solar system resident, but another visitor from interstellar space, like 3I Atlas. However, the initial eccentricity measurement had a large uncertainty. By integrating its orbit backward in time to a distance of 1,000 astronomical units, Dr. Loeb's calculations suggested that V1's eccentricity drops below 1, indicating that it is most likely an Oort cloud comet, a natural, icy resident from the outermost reaches of our own solar system. The scientific consensus, therefore, is that V1 is a normal, if steeply inclined, comet. But the timing and the geometry, you realize, resist this easy closure. This is the second uncanny coincidence. V1 was discovered just after 3I Atlas reached its maximum activity, and its orbit brought it relatively close to where 3I Atlas was in October. The closest separation between the two objects' orbits is 75 million kilometers. This proximity prompts Dr. Loeb to ask the provocative question: could V1 be a fragment or a mini-object that broke off from 3I Atlas? If it were a natural fragment ejected by the non-gravitational acceleration, the measured force is not large enough to explain V1's current position, as the objects were never closer than 225 million kilometers without some additional propulsion. This introduces the key point. For V1 to be a subcomponent of 3I Atlas, it would require its own propulsion system, its own way of adjusting its trajectory after separation from the main body. This, like the high jet velocity, would be an unambiguous techno-signature. The mystery deepens with the observation of V1 itself. It does not have a visible cometary tail or coma. Early images show a simple, faint point source. This is unusual for an object that, based on its orbit, should be close enough to the Sun to be actively outgassing ice. If it is an Oort cloud comet, its lack of activity suggests it might be a dormant comet, its icy surface covered by a non-volatile, insulating crust of dust. If it is an asteroid, its Oort cloud origin becomes puzzling, as the Oort cloud is predominantly icy material. You see, the appearance of V1 offers a crucial framework for evaluating 3I Atlas. Scientists look for patterns. One anomaly is a curiosity. 2 anomalies are a coincidence. 3 anomalies demand an explanation. We do not yet have 3 linked anomalies, but the possibility that V1 is either an improbably timed Oort cloud object or a piece of a larger technological puzzle is enough to warrant a dedicated, closer look. The latest images of 3I Atlas itself add to the sense of a fragmented design. They reveal a complex structure of at least 7 distinct jets radiating from the nucleus. If 3I Atlas is ejecting material in multiple, highly directional plumes, then we should expect to find not just one companion like V1, but a family of companions. Calculations suggest that the non-gravitational acceleration requires the ejection of several billion tons of material, enough to create dozens or hundreds of discrete objects. This re-emphasizes the urgency of the December 19th closest approach. The observation strategy must be broad. We need wide-field surveys, to map the entire space around 3I Atlas, covering a region of millions of kilometers. If these mini-objects are real, if the perpendicular jets are the sign of an entire deployment, they will show up as faint dots against the background stars. The discovery of V1 serves as a quiet, powerful reminder that the universe is under no obligation to adhere to our comfortable models. It forces us to ask, are we witnessing a singular, extraordinary natural event, or the deliberate deployment of an interstellar armada? The scientific community's resistance to this question stems from the belief that challenging the consensus requires an enormous expenditure of resources. Dr. Loeb, however, argues that the history of science shows that progress happens precisely when the consensus is challenged, when one is willing to admit that the model is incomplete. Where are you listening from tonight? And what is your own quiet assessment of this uncanny coincidence? Do you see two entirely separate, random objects, or the subtle beginnings of a pattern too vast to ignore? The only path to the truth is to set aside our preconceptions and look with an open, honest, and humble gaze. Time is running out for the observations that could resolve the question of V1 and the wider family of mini-objects. Our quiet journey into the mysteries of 3I Atlas must pause to reflect once more on a crucial human element: the lost time. The 41 days of the government shutdown that created a data blackout during the object's most revealing phase. This is not a matter of conspiracy, but of the severe cost incurred when scientific opportunity collides with political dysfunction. Imagine the scientific community in the days leading up to October 1st, 2025, the start of the shutdown. Every astronomer knew that the object was approaching its closest point to the Sun, or perihelion, on October 29th. This period was the peak of its activity, the only time it would be bright enough to yield the high-resolution spectra and images necessary to determine its true nature. The spacecraft, the orbiters at Mars, the solar-observing missions, were already scheduled to capture data, a passive, automated process. But the critical human link, the scientists who process, calibrate, and release that data, was severed. The images from the Mars Reconnaissance Orbiter, which captured the first evidence of the X pattern on October 2nd, sat for 48 days before their public release on November 19th. This delay was a catastrophic loss of strategic time. If the scientific world had seen the X pattern in real time, in early October, there would have been a crucial 4-week window to execute follow-up observations. You must understand that the scheduling of premier telescopes, like the Hubble and James Webb Space Telescopes, requires months of advance notice. Only an extraordinary, time-sensitive event, a target of opportunity, can disrupt this queue. The immediate release of the X-pattern image would have provided the necessary scientific justification to retarget those instruments while the object was still at its brightest. Instead, the opportunity was missed. By November 19th, the object was already moving away from the Sun, getting dimmer, and its jets were weakening. The optimal window for measuring the critical parameters, the velocity and composition of the jets, had closed. The cost of this lost time is quantifiable. We may have failed to collect the definitive data that would have provided a clean answer to the central question. The non-gravitational acceleration, the small deviation in the orbit that could have been caused by either natural outgassing or a technological thrust, was only fully analyzed and released by the European Space Agency, who were unaffected by the American shutdown. Furthermore, the data blackout created a dangerous information vacuum. When official institutions go silent, the public does not stop being curious. They simply turn to less reliable sources. The wild, unsubstantiated claims that spread during October and November that the object had changed course toward Earth, or that radio signals had been detected, were a direct result of the delayed, cautious release of information. The very secrecy that was intended to prevent speculation instead became the central proof of a conspiracy in the public mind. Dr. Loeb's persistent and public questioning of this delay is rooted in a fundamental scientific principle. Transparency builds trust. In a situation of high ambiguity, the only way to counter misinformation is to release all available data to the global community, allowing independent researchers to analyze and debate the findings openly. The cautious, slow approach, while intended to protect scientific integrity from sensationalism, instead risks confirming the worst fears of the public. The mythic lesson of the data blackout is that of the gatekeepers. The resistance Dr. Loeb faces is not always about the science. It is about institutional inertia, the unwillingness to grant precious telescope time to a hypothesis deemed fringe, and the ingrained desire to protect the status quo. The scientific process is designed to be conservative, to protect against the premature announcement of monumental discoveries. But sometimes, this very conservatism is what causes us to miss the extraordinary, to prioritize the predictable over the anomalous. You may reflect that our civilization is now faced with a profound paradox. We have the technological capability to detect a tiny, fast-moving object from another star system, yet we lack the institutional agility to mobilize our resources effectively when the discovery is controversial. The cost of the shutdown, you must realize, may not just be the loss of a few images. It may be the loss of the only clean, definitive answer we will ever get to the question of whether we are alone. As 3i Atlas moves toward its final observable phase, we must move on with the quiet knowledge that the time for a definitive answer is almost past. The focus must now shift entirely to the small window remaining, the approach to December 19th, to get the last, best look at the mystery before it is swallowed by the interstellar void. The core of the mystery, the hinge on which the entire debate between an icy comet and a technological probe swings, is a single measurement: the velocity of the ejected material. This measurement, which can only be achieved through the delicate art of spectroscopy, holds the key to determining the nature of the object's power source. You must understand the physics of outgassing. When 3i Atlas approached the Sun, the heat caused the ices on its surface to sublimate, turning directly into gas. This process, governed by the laws of thermodynamics, limits the speed at which the gas can escape. The maximum velocity of gas produced by this simple passive heating, the speed of sound in the gas at a few hundred degrees, is approximately 400 meters per second. This is the expected, natural velocity. If the velocity of the jets is measured to be 400 meters per second, the conclusion is straightforward. The process is natural sublimation, and 3i Atlas, despite its extraordinary anomalies, is a comet. However, if the velocity is significantly higher, the natural explanation collapses, and the presence of a powerful, non-natural energy source becomes undeniable. This is because it takes a vast increase in energy to accelerate gas to higher speeds. A velocity of several kilometers per second, for instance, would require a process far more energetic than solar heating. A chemical rocket, such as those used by human spacecraft, produces exhaust velocities in the range of 3 to 5 kilometers per second. An ion thruster, a highly efficient propulsion system, produces exhaust velocities in the range of 10 to 50 kilometers per second. If the measured velocity of the gas in the jets is in the range of 1 to 2 kilometers per second, it suggests an energetic event beyond simple sublimation, possibly an explosive release of supervolatile ices, or, more compellingly, a low-powered technological thruster. If the velocity is 3 kilometers per second or higher, you are looking directly at a techno-signature. The physics, in this case, would speak for itself. The technique for this measurement is high-resolution spectroscopy. Light from the comet's jets is collected and spread into a spectrum, revealing the distinct absorption or emission lines of the molecules present, such as carbon dioxide or water vapor. Crucially, the light emitted by a gas moving away from an observer is slightly stretched, shifting the spectral lines toward the red end of the spectrum, known as the Doppler shift. Conversely, gas moving toward the observer causes a blue shift. By precisely measuring this shift, astronomers can calculate the exact velocity of the gas. The quiet tragedy of the data blackout, the government shutdown, is that this definitive measurement requires time on the most sensitive instruments. The James Webb Space Telescope, with its exquisite sensitivity, is the ideal tool for obtaining high signal-to-noise ratio spectra of the faint jets during the closest approach in December. This spectroscopy, combined with measurements of the gas temperature, is the acid test that Dr. Loeb is urgently requesting. The debate surrounding the impossible 50 billion tons per month mass loss rate also hinges on this velocity. That immense mass loss calculation assumes the low, natural velocity of 400 meters per second. If the actual velocity is, say, 2 kilometers per second, the required mass loss drops by a factor of 5 to a more sustainable 10 billion tons per month. Thus, a high velocity not only reveals a technological power source, but also resolves a major physical paradox under the natural hypothesis. You must understand that the resistance to performing this simple yet powerful observation is philosophical. The astronomical community is reluctant to dedicate precious, oversubscribed telescope time to a project whose justification is a low probability hypothesis, arguing that it would legitimize fringe theories. But the quiet truth is that the necessary observations are standard practice. The only barrier is the justification for the request. The mythic reflection here is the concept of hylomorphism, the philosophical idea that every object is a compound of form and matter. Here, the matter is the ice and rock, but the form, the trajectory, the geometry, the high-velocity jets, is what suggests the guiding hand. The universe has given us an object of unknown form, and all we need is a clean, definitive number to classify its essence. Where are you listening from tonight? As we wait for this number, the number is the truth, and it is a truth that cannot be argued away with rhetoric or caution. It is a cold, hard fact, waiting to be captured by a spectrometer. The question is whether the scientific community will mobilize in time to capture it before the object slips away into the interstellar night, forever withholding its secret. Beyond the velocity of the gas, a second critical measurement awaits collection during the closest approach of 3I Atlas, the composition test. The question here is not how fast the material is escaping, but what the material actually is. A natural comet's coma and jets should be a predictable inventory of volatile ices, while an artificial object might betray its origin through an unusual chemical signature. The James Webb Space Telescope, the most powerful infrared observatory ever built, has already performed an initial composition analysis. In August, when 3I Atlas was still far from the Sun, the telescope's spectrograph confirmed the presence of the expected cometary volatiles: carbon dioxide, water, carbon monoxide, and carbonyl sulfide. This initial finding was entirely reassuring to those who maintained the object was purely natural. However, the composition of 3I Atlas presents a series of subtle anomalies that challenge the familiar model. First, the low water content. The gas plume contains only a small amount of water by mass, much less than is typical for familiar solar system comets. While this can be explained by the object being a carbon dioxide-rich comet, it is nevertheless an outlier. Dr. Loeb has speculated that this low water plume could also result from sunlight releasing ices and dust that simply accumulated on the surface of a solid, technological object during its journey through the cold interstellar medium, rather than from the bulk sublimation of a deep, icy core. Second, the nickel detection. Some observations have reported the unexpected presence of atomic nickel vapor in the gas plume. Nickel is not common in comets, and when present, it is usually in trace amounts. The existence of nickel, if confirmed, points to a highly unusual formation history for the object, one that is different from solar system comets. But the most compelling anomaly is the unnatural nickel to iron ratio. Further analysis suggested that the gas plume contains much more nickel than iron, an abundance ratio that is orders of magnitude larger than that of all known comets. This specific ratio is highly perplexing in a natural context, as nickel and iron are heavy elements that should be released in a more balanced cosmological proportion. Dr. Loeb's hypothesis zeroes in on this metallic anomaly. Nickel alloys, such as those used in stainless steel and high-performance electronics, are common materials in industrially produced technological objects. A spacecraft, for example, is composed of various alloys to maximize structural integrity and minimize weight. If the object is an alien probe, the intense heat near the Sun could be sublimating not just the volatile ices coating the surface, but also trace amounts of the metallic infrastructure beneath, creating the unusual, non-natural nickel to iron signature. You, the quiet observer, are faced with a subtle chemical argument. Is the nickel just a rare, natural component of an interstellar iceberg, a unique signature from a star system with a different metallicity than our own? Or is it the faint, spectral whisper of a structure that was manufactured? The final, definitive composition test awaits the December 19th closest approach. High-resolution spectroscopy at this time will have the highest signal-to-noise ratio, allowing astronomers to confirm the presence of these metallic elements, measure their precise ratios, and search for any other unexpected elements or compounds that do not belong in a comet. The detection of any artificial material or a definitively non-cosmological ratio would be a chemical technosignature. The mythic reflection here is the idea of the object of manufacture. Throughout history, the presence of an object made with an unnatural level of complexity or a non-native material, a Roman coin found in a Viking grave, or a piece of polished jade on a remote island, has been the irrefutable evidence of a visitor from elsewhere. The nickel anomaly is the cosmic version of that coin, a faint, metallic glint in the gas plume, suggesting a traveler who did not simply accrete from a random cloud of dust and ice, but one who was forged. Where are you listening from tonight? Where the simple inventory of elements in a gas cloud can lead to such profound speculation. We are poised for a definitive test, a chemical analysis that will tell us whether we are dealing with a relic of stellar nurseries or the byproduct of an extraterrestrial foundry. This chemical signature, this silent testimony of the elements, is one of the last, best hopes for a clean, unambiguous answer. Let us return once more to the core physical paradox, the quiet challenge posed by anomaly number 12. The jet orientation is not smeared by rotation. This is the most visual and visceral anomaly, a question of simple geometry that most forcefully argues against the conventional cometry model. You should visualize the two pieces of conflicting data. On one hand, we have the comet's measured rotation. In July and August, independent observers confirmed that 3I Atlas spins on its axis with a period of 16.16 hours. In the vacuum of space, this rotation rate should persist indefinitely, as there is no mechanism to stop a rotating body. On the other hand, we have the observed jet columnation. Images taken in November, including the X pattern, show the jets extending up to 1 million kilometers in tightly columnated, perfectly straight beams. Now, apply the simple physics of the spinning sprinkler once more. Over the 22 days it took for the gas and dust to travel 1 million kilometers from the nucleus, the main body would have completed approximately 45 full rotations. Any material being ejected from a fixed vent on that spinning surface should have been launched in 45 distinct puffs or arcs, resulting in a wide, visible, spiral smear in the jet structure. The image shows no gaps and no wiggles. Dr. Loeb laid out 3 possible explanations for this defiance of expected physics. 1. The natural fragmentation hypothesis. The straight jets represent the evaporated trail of large fragments that were ejected from the main nucleus in a single, explosive event near the Sun. The fragments themselves would travel in straight lines, and the gas and dust they release would trace those straight lines. The problem is that this requires the nucleus to have exploded, which contradicts the observation that the nucleus remains a single, intact body. 2. The active vents hypothesis. The jets maintain their directionality because they are produced by natural vents that only turn on when they are heated by the sun, only when they face the solar direction. If the vent is active only for a fraction of each rotation, you might get a jet that appears relatively straight. This is theoretically possible, but it requires a very specific and highly unusual rotation and heating scenario to maintain columnation over 1 million kilometers, making it a stretch even under the natural model. 3. The technological thrusters hypothesis. The jets are produced by technological thrusters on board independent mini-objects. These objects, the probes, actively preserve their global orientation for navigation purposes. overriding the rotation of the main body. Because they are self-guided and not tethered to the main body's spin, they can travel in a perfectly straight line. This is the most elegant explanation for the geometric precision. The X pattern, with its sideways jets that are perpendicular to the solar direction, makes the technological hypothesis even more compelling. The jets cannot be explained by a simple sun-facing vent, as they are pointed sideways. Their continued straightness is a direct visual indictment of the natural, passive cometary model. The mythic reflection here is the idea of the immovable trajectory. In ancient myths, a celestial object that maintained a perfect, unwavering course, indifferent to the rotation of the heavens, would have been seen as guided by a divine or intentional hand. This is the challenge 3I Atlas presents: a trajectory too precise, a geometry too perfect to be comfortably attributed to the chaos of a spinning, melting ice ball. The only way to resolve this is through high-resolution imaging during the closest approach on December 19th. We need to confirm whether the main nucleus is truly single, or if there are multiple, small, discrete objects in its immediate vicinity. And we need to measure the outflow velocity to see if the material is escaping at a speed that only a rocket, and not a passive ice vent, can produce. Where are you listening from tonight as we contemplate this geometric paradox? The rotation of the universe is relentless, yet this tiny visitor appears to be actively resisting its spin. This quiet defiance is a powerful argument for intentionality, a profound reminder that we must not let our preconceptions blind us to a reality that may be stranger and more sophisticated than we can imagine. Having established the profound geometric and kinetic anomalies, our quiet contemplation naturally shifts to the most audacious possibility: the probes and the mothership scenario. This is the hypothesis that weaves the anomalies into a coherent, if unconventional, narrative, offering a reason for the object's improbable trajectory, its strange jets, and the precision of its planetary flybys. You must understand that this scenario is not derived from science fiction. It is derived from our own best practices for deep space exploration. Imagine a civilization with a technological maturity far exceeding our own. They want to study a new star system, but the journey takes billions of years. They cannot simply send a slow, lumbering spacecraft. Instead, they launch a highly durable, autonomous vehicle, the mothership, designed to withstand the rigors of interstellar space. This mothership, cloaked in a protective, icy mantle, to survive the journey, enters our solar system on an optimized, fast-moving trajectory. This is 3I Atlas, traveling at a hyperbolic excess velocity, too fast to be captured by the sun's gravity. The reconnaissance mission has a specific goal: to study the habitable and geologically interesting planets, Earth, Mars, and Jupiter. But a single spacecraft on a single flyby trajectory cannot get close enough to multiple, widely separated targets. The solution is the deployment of mini-probes. The scenario unfolds as follows. First, the perihelion deployment and fine-tuning. As the mothership reaches its closest approach to the Sun perihelion on October 29th, it uses the extreme thermal stress to shed its mantle, or perhaps activates its thrusters for a precise, concealed maneuver. The non-gravitational acceleration detected at this time is not random outgassing, but the minute, calculated thrust needed for a course correction, specifically to target Jupiter's Hill radius. At the same time, it deploys a swarm of smaller, independent probes. Second, the X pattern and independent trajectories. The X pattern, the perpendicular jets, is the visible signature of this deployment. The mini-objects, each with its own tiny propulsion system, are launched at specific angles to execute their independent reconnaissance missions. One set of probes might be targeting the inner solar system, and another, perhaps, is launched sideways, perpendicular to the solar axis, to conduct a wide-field survey of the inner plane. Since each probe has its own attitude control system, the straight, unsmeared jets observed over 1 million kilometers are easily explained. They are maintaining their course, independent of the mothership's rotation. Third, the targeted rendezvous. The mothership continues on its primary hyperbolic path, but the probes, released with a slight velocity boost, begin their specialized missions. Some adjust their trajectories to ensure a close pass by Earth and Mars, while others use the velocity to execute the Jupiter seed maneuver, aiming for the energetically stable Lagrange points near Jupiter's Hill radius. The profound truth about this hypothesis is that it elegantly resolves nearly all 12 anomalies. Anomaly, ecliptic alignment, and flybys. The trajectory is not random, it is optimal for multi-target reconnaissance. Anomaly, X pattern, and no smearing. The jets are not passive outgassing, they are the trails of actively guided independent subcomponents. Anomaly, persistent anti-tail. This could be the exhaust of a low-level, long-term thruster, maintaining the object's orientation against the solar wind. Anomaly, nickel anomaly. The sublimation is stripping away not just ice, but the metallic infrastructure of the craft beneath. Dr. Loeb's ultimate point is that this is a logically consistent scenario that fits the data. It requires us to abandon the assumption of randomness and instead consider that our solar system is being observed by a civilization with a scientific curiosity and technological capability that mirrors our own best exploratory efforts. The mythic reflection here is the idea of the emissary. If 3I Atlas is a probe, it is a message in a bottle, possibly launched billions of years ago by a civilization that may no longer exist. The object itself becomes a monument to a long-dead culture's enduring curiosity. Or, and this is the more unsettling possibility, the civilization is still out there, still watching, waiting to see what its probe finds. As you settle deeper into the quiet dark, consider the final, crucial question. How would we detect these mini-objects? We must look now, in the final, narrow window before the closest approach on December 19th, to see if we can spot the discrete, fast-moving dots in the sky, the irrefutable evidence of the probe's independent missions. The hunt is on for the tangible proof of an intelligence that visited us long ago. In the face of profound ambiguity, the human mind seeks a framework for evaluation, a scale to measure the extraordinary. Dr. Avi Loeb, recognizing the philosophical burden of classifying an object that defies conventional science, proposed a ranking system called the Loeb scale. This scale runs from 0 to 10, offering a method to assign a level of plausibility to the artificial hypothesis, based purely on observable anomalies. You may think of the Loeb scale as a quiet scientific consensus builder, a structured way of dealing with the question of intentionality. 0 on the scale means the object is definitely natural, perfectly explained by the physics of ice, rock, and gravity. 10 on the scale means the object is definitely artificial, potentially threatening, with irrefutable evidence of technological origin. As of late November, 3I Atlas is formally ranked at 4 on the Loeb scale. This is a crucial number. A ranking of 4 means there are multiple unexplained features, the 12 anomalies that do not fit the standard model, but there is no definitive, smoking gun proof of artificiality. The natural explanation remains the most cautious and most socially acceptable. A ranking of 4, however, is significantly high enough to demand a serious investigation. It is a yellow flag, a warning that the default assumption is likely incomplete. It is the scientific justification for Dr. Loeb's persistent calls to dedicate premier telescope time, arguing that the object warrants an immediate, full-scale campaign. To move 3I Atlas higher on the scale, to push it to 5 or 6 or 7, we require the kind of extraordinary evidence that an object of this nature can provide. This evidence must be a technosignature, a piece of data that is impossible to explain through any natural process, no matter how exotic. The essential technosignatures we are hunting for, the ones that will immediately raise the Loeb scale, are, first, a kinetic signature, a measured gas velocity of several kilometers per second from the jets. This would irrefutably prove an internal, high-energy power source beyond solar heating. Second, an infrared signature, the detection of an infrared anomaly, a heat signature that is warmer than the surrounding environment and inconsistent with passive solar heating. This would suggest an internal energy source, a power core, or a functioning electrical system. Third, a compositional signature, the detection of a non-cosmological abundance ratio of elements, such as the unusual nickel to iron anomaly, or the presence of an element or compound that simply does not belong in a natural comet. Fourth, a structural signature, the detection and tracking of the mini-objects, the proposed probes, and the demonstration that they are maintaining a stable trajectory with active course corrections, a behavior impossible for tumbling ice fragments. Fifth, an electromagnetic signature, the detection of a deliberate, non-random radio signal or a focused laser pulse. Though the initial radio search was negative, the possibility of a laser transmission or a signal outside the tested frequency range remains. The quiet philosophical debate revolves around the concept of the burden of proof. The bar for announcing an extraterrestrial technological object is immensely high. Astronomers will want to rule out every last, remote, natural explanation before they even consider the artificial one. Dr. Loeb argues that this caution, while appropriate, must not be used as an excuse for inaction. We cannot achieve extraordinary evidence without first making extraordinary observations. The next few weeks, leading up to the December 19th closest approach, are the last chance to push 3I Atlas higher on the Loeb scale. If the observations from that time yield a single, irrefutable technosignature, the smoking gun, the debate will end. The truth will come out, not on a day of dramatic announcement, but in the slow, meticulous publication of a peer-reviewed paper. As you reflect on the strange beauty of this ranking system, consider the quiet courage required to even propose such a scale. It is an invitation to the scientific community to move past its fear of being wrong and to humbly accept that the universe may be stranger than our terrestrial models predict. The ultimate goal is not to prove the existence of aliens, but to follow the evidence wherever it leads, even if it leads somewhere uncomfortable. The truth is waiting, a number between 4 and 10, hidden in the light of a distant, fast-moving object. The quiet narrative arc of 3I Atlas converges on one crucial date, December 19th, 2025. This is the day the interstellar object reaches its closest point to Earth, marking the final, best opportunity for the definitive observations that could resolve the entire mystery. You must understand that this day is not about proximity. It is about photons and resolution. On December 19th, the object will be 269 million kilometers from Earth. This is not particularly close, but it is about 20% closer than it was in late November, which translates to the object being about 44% brighter. This increase in light, the photon count, is significant, providing the maximum signal-to-noise ratio for the most demanding measurements. The two main observational goals for this final window are, first, high-resolution imaging for structure. The closer distance improves the angular size of the object, while the Hubble Space Telescope's resolution will still only allow it to resolve features down to about 250 kilometers. This is enough to detect clustering, grouping, or any kind of organized structure in the coma. Crucially, a coordinated wide-field survey could finally resolve the discrete objects the proposed mini-probes in the 2.2 million kilometer halo surrounding the main nucleus. The ability to see any separation or clustering would be a powerful data point in the structural signature. Second, high sensitivity spectroscopy for velocity and composition. The James Webb Space Telescope, with its immense light-gathering capability, can utilize this peak brightness to capture the most detailed spectra of the jets. This is the time to perform the definitive velocity test, measuring the Doppler shift to see if the gas is escaping at the expected 400 meters per second, or at a higher, artificial velocity of several kilometers per second. This is also the time to perform the final composition test, looking for unexpected metals, a high nickel-to-iron ratio, or any other chemical anomaly that might point to a manufactured origin. The quiet urgency is rooted in the object's hyperbolic trajectory. After December 19th, 3I Atlas will continue to move away from the Sun and Earth. It will pass Jupiter in March 2026, and then it will leave the solar system entirely, heading back into the interstellar void at 60 kilometers per second. By the end of 2026, it will be too far for any telescope to see. It will be gone forever. The opportunity to collect the definitive, high-quality data will be irrevocably lost. The mythic undertone of this final window is the concept of the last chance, the memory of one, Oumuamua, the object we failed to study adequately, hangs heavy over this observation window. We made the mistake once, failing to capture the high-resolution data that could have resolved its non-gravitational acceleration mystery. The scientific community now faces a moral obligation not to repeat that failure. Dr. Loeb argues that the potential payoff, the discovery of the first sign of extraterrestrial technology, is so high that it overrides the cautious resistance of the astronomical establishment. You may reflect that the outcome of this final observation window has three distinct possibilities. First, the conventional confirmation. The data confirms that 3I Atlas is natural. The jets are 400 meters per second. The composition is ordinary, and there are no discrete objects. The mystery is resolved. It is the most anomalous natural comet ever observed, but still a comet. Second, the definitive revelation. The data reveals a techno-signature. Jets are moving at several kilometers per second. An infrared anomaly points to internal power, or independent mini-objects are maintaining a stable, non-gravitational trajectory. This would be definitive proof, ending the debate instantly. Third, the ambiguous continuation. The data is inconclusive. More anomalies are found, but each can be explained naturally with enough assumptions, yet also fit the artificial hypothesis. The debate continues. The scientific community splits, and the public is left in a state of confused suspicion. This, Dr. Loeb suggests, is the worst outcome, as it undermines public trust. The quiet tension remains. Will the political and philosophical resistance to the artificial hypothesis prevent the necessary observations from being made, or will the scientific imperative finally prevail? The truth will only be revealed through the data, and the data must be collected now. December 19th is not just a date, it is a moment of profound choice for humanity, a moment when we decide how much we truly want to know about our place in the cosmos. The meticulous preparation for this final viewing window extends beyond the hardware and the scheduling. It is a profound exercise in anticipation, a deliberate attempt to overcome the inherent chaos of the cosmos with the focused clarity of human intent. We must consider the immense difficulties inherent in observing an object moving at 68 kilometers per second, which translates to over 150,000 miles per hour, an extraordinary speed that pushes the limits of our tracking systems. The great telescopes are not merely pointing, they are performing a delicate celestial choreography, constantly adjusting their gaze to follow a visitor that is both incredibly far away and impossibly fast. This act of tracking, in itself, is a testament to the decades of engineering and mathematical precision that allow us to hold this tiny, faint object steady in the crosshairs of a gigantic billion-dollar mirror. The need for precision targeting becomes even more critical when we consider the search for the mini-objects, the potential probes that created the astonishing X pattern. As the object reaches its closest approach on December 19th, we cannot simply look at the center of the coma. We must perform a vast, wide-field survey that covers the entire 2 million kilometer radius around the nucleus, an area that is gigantic in terrestrial terms, but small on a cosmic scale. This survey is the equivalent of trying to spot a pinhead in a stadium using a magnifying glass while the stadium is moving at high speed. If the mini-objects are small, only a few meters across, which is entirely plausible for sophisticated probes, they will be incredibly faint, barely distinguishable from the background noise of distant stars. We are hunting for a slight, sudden flicker, a persistent point of light that defies the expected dispersal of cometary debris. The ability to find them rests entirely on the extreme sensitivity of the James Webb Space Telescope, or Webb, particularly its near-infrared camera, or NIRCam, which has the ability to see things that are merely warm, but not hot. Should we detect a handful of these discrete, smaller objects, the next step becomes the kinematic confirmation. We must track their motion over a period of days, weeks if possible, to see if they maintain a stable trajectory. Natural fragments will quickly succumb to the chaotic forces of asymmetric outgassing and the subtle gravitational tugs of the main nucleus, causing them to tumble and spread out in a predictable, non-linear fashion. Technological probes, however, would demonstrate non-chaotic motion, a stable, straight-line path, or even a subtle, measured deviation from a hyperbolic course, a minute course correction that betrays an active navigation system. The data from their trajectories, their speed and vector over time, would be the primary evidence for intentionality. You see, the universe, as far as we know, does not produce straight lines in the trajectories of tumbling objects. Only mind, only design, only purpose can command a truly straight line. The consequences of the definitive revelation are so immense that they almost eclipse the science. If a techno-signature is confirmed, if the jets are measured at 3 kilometers per second, or if a cluster of mini-objects is found executing a stable, targeted trajectory toward Jupiter, the event would instantly redefine human civilization. Every cultural narrative, every philosophical and religious certainty would be forced into a collision with the reality of an external, greater intelligence. This would not be a gradual discovery. It would be a moment of sudden, profound global awakening. An awakening that is both terrifying and exhilarating. The world, as you know it, would change in the span of a single scientific paper. This realization places an immense, almost impossible pressure on the astronomers and the institutions involved. They are the unwitting custodians of this potential, world-altering truth. The quiet tension is that the final window, the period around December 19th, is not just a scientific deadline. It is a moment when humanity faces its own ultimate report card, a test of its intellectual honesty. Did we use our best tools? Did we ask the hardest questions? Did we overcome our own fear of the extraordinary? As the faint, fast-moving light of 3i Atlas races past its closest point, the answer, whatever it is, will be written in the cold, hard numbers of the universe, numbers that no one, not even the most cautious scientist, can ignore. We hold our breath, waiting for the final word from the great, silent visitor. This moment, the subtle tension of the final approach, highlights the vast difference between an observation and an interpretation. An observation is a measured data point, a specific velocity, or a definitive image of separation. An interpretation is the story we tell about that data point. Up until now, the mainstream has maintained that the story must be one of natural processes. But the final, high-fidelity data from December 19th is the last chance for the object itself to tell its own story. We must listen to the numbers. The detection of a significant concentration of the gas in the jets moving toward the observer, or blue-shifted, at a non-natural velocity, would be the most difficult piece of evidence to dismiss. Such a detection would require a sustained thrust pointing directly at Earth, a deliberate act of engineering that defies the randomness of cometary outgassing. The probability of a random vent on a tumbling comet just happening to point toward Earth at the moment of peak brightness and produce a supranormal velocity jet is almost vanishingly small. Therefore, this one measurement, the velocity of the blue-shifted gas, holds the greatest potential for an unambiguous techno-signature. The challenge now is to ensure that the scientific community has the collective will to face an answer that could force them to rewrite their textbooks. Our quiet reflection now focuses on the internal, human struggle within the scientific community, the political cost of scientific caution. The resistance doctor, Avi Loeb faces is not always based on mathematical refutation, but on a deep institutional reluctance to legitimize a highly unconventional hypothesis, a reluctance that risks blinding us to an extraordinary reality. You must understand the professional culture of a premier astronomical institution. Telescope time on the Hubble or James Webb Space Telescope is the most precious resource in the field, allocated through a highly competitive, peer-reviewed process. Proposals are judged on scientific merit and the likelihood of producing publishable results. The consensus among most mainstream astronomers is that 3I Atlas is a natural comet, however strange. Therefore, dedicating vast, expensive telescope time to test the artificial hypothesis is viewed as a low probability bet and a misuse of public resources. The fear is that if the hypothesis is taken seriously, the door will open to a flood of similar claims, every oddly shaped asteroid becoming a potential spacecraft, drowning the signal-to-noise ratio of legitimate science. This cautious approach, however, carries a significant political cost. First, the failure of inquisitive humility. The fundamental duty of a scientist is to observe, question, and seek the truth wherever it leads, without prejudice. The current stance risks intellectual cowardice, prioritizing the protection of reputation and professional consensus over the rigorous investigation of a genuine anomaly. Dr. Loeb argues convincingly that the way to maintain scientific credibility is not to ignore anomalies, but to investigate them rigorously and transparently. Second, the reinforcement of conspiracy. The cautious language of NASA, constantly reiterating that all evidence points to it being a comet, combined with the delayed release of crucial images, feeds the perception that something is being hidden. The very act of being too cautious about sensationalism creates an information gap where conspiracy theories thrive. The public is left to choose between the official, highly conservative narrative and the wild, but emotionally resonant, speculation. Third, the risk of missing the profound. The historical precedent of 1I Oumuamua is a silent warning. We missed the definitive data on that first visitor due to the same inertia. If 3I Atlas is artificial, if there is even a small 0.1% chance, the cost of not investigating it is the loss of the most important scientific discovery in human history. We would have allowed an interstellar probe to fly through our solar system without collecting the data that would prove we are not alone. Dr. Loeb's approach is a direct challenge to this culture. He is a model of transparency. He publishes his calculations on his blog, invites criticism, and debates his reasoning openly, even when it draws fire from his colleagues. He is forcing the debate into the public and intellectual spheres, arguing that science is not just for scientists, but for everyone. The mythic reflection here is the concept of the prophet in the wilderness. Dr. Loeb, by challenging the status quo, is accused of sensationalism and attention-seeking. Yet, the quiet evidence, the 12 anomalies, the X pattern, the fine-tuned trajectory, speaks with a voice that is both rigorous and genuinely puzzling. His refusal to back down is a stand for the pure scientific process, the willingness to follow the data, even if it leads to a conclusion that is professionally dangerous. Where are you listening from tonight as we witness this internal conflict? The truth is not just an astronomical problem, it is a sociological one. The scientific community is currently debating whether the object is a technological artifact or a natural wonder, and in doing so, they are also debating their own role in the public eye. The question is not whether the scientists are smart enough to figure it out, but whether they are brave enough to look. The political cost of being wrong is high, but the philosophical cost of not looking is infinite. The subtle but powerful dynamic of the political cost of scientific caution is fundamentally a problem of paradigm preservation. Mainstream science operates within a carefully constructed set of assumptions, a paradigm that dictates what is considered plausible and what is considered extraordinary. The current paradigm holds that life is likely common in the galaxy, but technology is either rare or so far away that it has never been detected in our solar neighborhood. Dr. Loeb's hypothesis that a technological artifact is right here, right now, challenges the very foundation of this comfortable consensus. The inertia of the established view is a force of resistance as powerful as any gravitational field. The institutional resistance manifests in several distinct ways. Firstly, there is the curse of the fringe. Once a respected scientist ventures into a field traditionally associated with less rigorous research, they risk a permanent professional downgrade, a loss of reputation that can last for decades. This fear is a powerful, self-regulating mechanism within the scientific community, ensuring that only the most robust, ironclad data is ever presented as evidence. However, this mechanism is ill-suited for the truly extraordinary, where the probability of a discovery being revolutionary is inversely proportional to the probability of it being a false alarm. The political cost is the lost opportunity to be the first to look, to take the necessary risk. As you settle into the quiet of the night, consider that the very structures built to find truth can sometimes become the greatest obstacles to its immediate revelation. Secondly, there is the allocation of capital. The world's premier telescopes, like the James Webb Space Telescope and the Hubble Space Telescope, are multi-billion-dollar investments, funded by public money and justified by consensus science. A request for a large block of observing time, say 100 hours, to search for a technological object on a 1 in 20,000 chance, is a significant budgetary and political risk for the administrators who grant that time. They must justify the choice to the peer review committee, and the community is generally conservative. This is where Dr. Loeb's public, outspoken nature becomes a critical, necessary force. By bypassing the traditional, closed-door peer review process and taking the debate directly to the public, he is attempting to create a public mandate for observation. He is leveraging the inherent human curiosity, the deep, abiding fascination with the question of cosmic company, to create a pressure that the institutions cannot easily ignore. The psychology of denial also plays a role. It is psychologically easier for a scientist to dismiss 12 minor, strange anomalies as a statistical fluke of a highly unusual natural comet than to accept the single, profound implication of a technological origin. To accept the latter is to admit that one's life's work in cometary science may be based on an incomplete model, one that did not account for the possibility of extraterrestrial engineering. This is a deep, intellectual hurdle that requires a rare form of philosophical humility. The subtle humor in this situation lies in the fact that the smartest people in the world are being momentarily outwitted, not by nature, but by their own perfectly designed system of caution. The crucial next step for Dr. Loeb and his team is to not only obtain the high-resolution data, but to package it in a way that is institutionally unassailable. They must publish their findings, whatever they are, with a level of rigor that is impossible to dismiss. If the velocity is 5 kilometers per second, they must not only show the spectral line shift, but also publish the raw data, the calibration process, the error bars, and the full analysis of any possible instrumental or atmospheric contamination. Only through this act of radical scientific transparency can the political cost of the hypothesis be neutralized. The truth, in the end, must be so clean, so pure, that it transcends the professional biases and fears of the cautious consensus. The clock continues to tick, and the political cost of inaction grows heavier with every passing hour. This professional anxiety around the topic of extraterrestrial technology is a fascinating historical pattern that repeats itself. In the 1960s, when the first radio searches for extraterrestrial intelligence were conducted, there was a similar fear of professional marginalization, a fear so pervasive that the early pioneers of the search for extraterrestrial intelligence, or SETI, had to work in secret or justify their work as purely basic radio astronomy. The quiet struggle of Dr. Loeb is simply the modern manifestation of this ongoing tension. The human need to categorize and sanitize the cosmic environment versus the universe's relentless insistence on providing anomalies. The risk is not the financial cost of a single observation. The true cost is the intellectual stagnation that results from prioritizing conformity over discovery. If science is to progress, it must retain its ability to be surprised. The fact that an object arrived precisely aligned with the planetary orbits, executed a course correction toward Jupiter's gravitational boundary, and possibly released smaller, high-velocity subcomponents, suggests a level of organization that should, at a minimum, trigger an all-hands-on-deck investigation, regardless of the cultural baggage associated with the search for technological signatures. The decision to observe or not to observe during the December 19th window is therefore a political and philosophical statement about the future of human scientific exploration. It is a quiet question about whether we, as a species, are ready for the answer that the universe might be trying to send us. The answer, in the end, will reveal more about us than it does about the object. Let us now allow our quiet contemplation to expand beyond the immediate scientific data and consider the profound philosophical implications of the technological hypothesis. The possibility that 3I Atlas is not a contemporary spacecraft, but an ancient relic, a message in a bottle from a long-dead civilization. You must first embrace the concept of galactic timescales. Our Sun and Earth are relatively young. The galaxy itself is billions of years old, and countless other stars and civilizations came and went long before humanity even existed. If a civilization a few billion years older than ours, one capable of launching an interstellar probe, existed on the other side of the Milky Way, their messenger would have been launched an impossibly long time ago. Dr. Loeb estimates, based on the object's speed and trajectory, that the journey for 3I Atlas could have taken billions of years. If this is true, the civilization that built it might no longer exist. Their star may have died, their planet sterilized by a supernova or gamma-ray burst. The probe, then, is a silent, enduring testament to their curiosity, an autonomous reconnaissance vehicle carrying data from a distant, long-forgotten time. This possibility is less unsettling than the idea of a current observer. A relic poses no threat. It is a monument, a quiet piece of history drifting through the cosmos. The only risk is the loss of the information it contains. The primary function of such a relic would be to observe, record, and store data, which it would then be programmed to transmit, perhaps via a tightly focused laser pulse, once it was safely outside the target solar system. The stealthy nature of 3I Atlas, its lack of an obvious radio signature, and its minimal infrared heat, especially when it was far from the sun, is entirely consistent with the design of a long-term, autonomous sentinel. It would use passive sensors, cameras, and spectrometers to observe the solar system and collect its data without advertising its presence. The mythic reflection here is the idea of the time capsule. You might imagine the probe to be a vessel containing the knowledge and scientific findings of a civilization that achieved interstellar capability, a quiet, metallic archaeologist programmed to sample the current epoch of our solar system. If we could somehow intercept its data or even retrieve the probe, we would be receiving a direct, unmediated communication from the deep past of the galaxy. Conversely, there is the more unsettling possibility that the civilization that launched it is still out there, still watching. In this scenario, the probe is an active emissary. Once it completes its reconnaissance, once the mini-objects complete their targeted flybys of Earth, Mars, and Jupiter, the probe would report back. This raises profound, difficult to answer questions. What would the probe report back? Would it send a simple, scientific data burst? Would it initiate a first contact by sending a deliberate signal toward Earth? Or would it simply maintain its silence, content to observe and record the growth of a new, noisy civilization in a quiet sector of the galaxy? We have no framework, no diplomatic protocol for contemplating the actions of an interstellar probe. The current goal is to use the final observation window not just to classify the object, but to search for any signs of these internal systems. The velocity test for thruster-speed exhaust, the compositional test for manufactured materials, and the structural test for independently moving mini-objects are all ways of trying to read the internal workings of this potential technological relic. Where are you listening from tonight, as we contemplate this object's immense journey? The universe, you must realize, has now introduced the possibility of a direct, tangible link to another intelligence. The scientific debate is no longer purely academic. It is a prelude to a profound cultural and philosophical shift. Whether 3I Atlas is a monument to the dead or a sentinel of the living, its presence forces us to confront the reality that we may not be alone, and that the history of our galaxy is far more complex than we had assumed. The final answer, in this quiet, cinematic moment, rests on the data, the final message this bottle might contain. The contemplation of 3I Atlas as an ancient relic, a message in a bottle, introduces the profound concept of interstellar archaeology. We are no longer just astronomers peering through a lens. We are archaeologists of the galaxy, sifting through the debris of time for the scattered artifacts of long-vanished civilizations. This perspective changes the nature of the investigation from a search for living beings to a search for enduring purpose. You must consider the immense technological requirements for an object to survive a journey of billions of years. It must withstand the constant bombardment of cosmic rays, the erosion of interstellar dust, and the thermal extremes of space. This necessitates a design based on materials far beyond our current engineering capabilities, perhaps self-healing structures, exotic metallic alloys that resist degradation, or an almost perfect form of shielding. The very survival of 3I Atlas in an intact state, despite the immense stresses of its close solar pass, suggests a structural integrity that is highly improbable for a loosely bound, natural rubble pile. This robustness, the object's sheer durability, is an enduring techno-signature, a silent testimony to its non-natural origin. The nickel anomaly, that faint trace of metal, becomes a spectral hint of this deep space industrial strength. If the object is a relic, its mission profile would be strictly passive and autonomous. The internal systems, the sensors, the data storage, the microreactors would be designed for minimal energy consumption, powering up only when necessary. This explains the initial silence, the lack of an obvious heat signature, and the sudden, precise activity near the Sun. The perihelion passage, with its extreme heat, would be used as a catalyst for activation, a natural trigger to shed the protective icy mantle and begin the terminal phase of its reconnaissance mission. The non-gravitational acceleration, therefore, is not a course correction for the next star, but a final, minute adjustment to ensure the best possible flyby geometry before the deployment of its subcomponents, the mini-objects. The deployment of these mini-objects, the probes, is the ultimate act of this interstellar archaeology. They are the instruments sent to gather the final, most valuable data on the current state of the solar system. Imagine the internal programming. After billions of years of silent travel, the probe is finally within the three-dimensional map of the planetary orbits, and it executes a protocol written by a long-extinct intelligence. One probe targets the atmospheric composition of Venus, another the subsurface hydrology of Mars, and a swarm is deployed toward Jupiter to study the magnetosphere and the icy moons. The X pattern, those perpendicular jets, becomes a deployment scatter pattern, a deliberate, efficient release mechanism designed to cover a maximum number of targets in the minimum amount of time. The data they gather is the most precious artifact of all. If the probe is still functioning, it is likely storing this information in a highly redundant, protected data core, programmed to transmit it home, or perhaps to a network of similar relics across the galaxy. The challenge for us, the archaeologists of the present, is to find a way to access that data before the probe leaves forever. This requires a leap of faith, a willingness to look for the tiny, subtle signs of industrial design within the immense chaos of the cosmos. The mythic reflection deepens here. We are not just looking for life, we are looking for the ghosts of a history that precedes our own. A history etched onto a fast-moving piece of non-natural metal encased in ice. The ultimate silence of 3I Atlas is the quiet voice of a civilization that finished its work eons ago, and we are privileged to be the recipients of its final, enduring curiosity. The idea of autonomy over aeons is central to this concept. A relic designed for a multi-billion-year journey would require levels of artificial intelligence and self-repair capability that dwarf our current engineering dreams. The probe would need to be its own mission control, constantly monitoring its systems, defending against micrometeoroids, and performing course corrections on timescales that are incomprehensible to us. The fact that the object is still intact and appears to be executing a complex, targeted maneuver suggests a remarkable degree of functional integrity. This level of enduring autonomy is in itself a techno-signature. Consider the concept of the von Neumann probe, a self-replicating spacecraft designed to explore the galaxy and seed new technologies, often theorized in the context of the Fermi paradox. While 3I Atlas is not self-replicating, its potential act of releasing a swarm of smaller probes, the mini-objects, is a functional analogy, a form of technological seeding within the gravitational boundary of Jupiter. This act would ensure that the core mission, the collection of environmental data, is completed efficiently. Furthermore, the object's sheer mass, 1,000,000 times greater than 1 Oumuamua, suggests that it was designed not for lightness, but for endurance and payload. A massive, shielded vessel capable of carrying both the protective icy shell and a sophisticated array of instruments and sub-probes. The weight of this history, this long, silent journey from a distant, unknown star, places a solemn responsibility upon us. We must honor the immense engineering feat that brought this object to our door, whether it was performed by nature or by design, and dedicate our utmost attention to its final, precious moments of visibility. Our survey of the techno-signatures must now move beyond the visible light and radio spectrum into the unseen realm of infrared and laser signatures. If 3I Atlas is indeed a stealth probe, it would be designed for minimal radio emissions, but it would still be subject to the fundamental laws of physics, specifically the law of energy conservation. Any technological object that uses energy, a functioning power source, a reactor, or even a solar panel converting light to electricity, will emit waste heat. This heat radiates as infrared light, and this is where the James Webb Space Telescope, or Webb, becomes the ultimate hunter. You should visualize the immense sensitivity of the Webb telescope. It can detect objects only a few degrees above absolute zero. If 3I Atlas possesses an internal power source, a power core that drives its thrusters or runs its sensors, that heat signature should make the object warmer than its surroundings and inconsistent with passive solar heating. The detection of an infrared anomaly would be a crucial piece of evidence. Webb did observe 3I Atlas in August, far from the Sun. At that time, its infrared signature was entirely consistent with the expected composition of a cold, natural comet, showing no unexpected thermal signature. This is the dilemma. A technological probe might be dormant when far from the Sun, activating its internal systems only when needed, such as during the stressful perihelion passage, or for the precision maneuvers around the planets. The critical, missing infrared data is from late October and early November, the period around its closest approach to the Sun, when the non-gravitational acceleration and the highly active jets were observed. If the jets were indeed powered by a non-natural source, the waste heat would have been at its maximum. Dr. Loeb and the scientific community are anxiously awaiting the release of any potential infrared spectroscopy from that critical time, data which is likely still being processed due to the data blackout. The search for the second major unseen signature is the laser pulse. As discussed, Advanced civilizations would favor highly focused laser beams for interstellar communication over dispersive radio waves. Laser communication requires less power and is thousands of times more efficient. The challenge is immense. You must be directly in the beam. If the probe is aiming its communication laser at its home star system, which is millions of light years away, and the beam passes within a few million kilometers of Earth, we would never see it. This is the inherent difficulty of optical SETI. However, the closest approach on December 19th provides a moment of opportunity. If the probe is programmed to perform a quick data dump before leaving the solar system, perhaps transmitting a wide-field burst to maximize its chances, ground-based optical observatories might be able to detect a powerful, brief flash of light. A coordinated search is necessary, but the difficulty of predicting the exact moment and direction of such a transmission remains the greatest hurdle. The mythic reflection here is the idea of the hidden lantern. The probe, if it is artificial, is not a broadcasting beacon, but a quiet observer, its light hidden by stealth technology or simply by the laws of physics. The silence, the lack of a detectable signal, is not evidence of absence, but a clue to its sophistication. A truly advanced civilization would understand the need to be unnoticed. Where are you listening from tonight? As we hunt for these unseen whispers, the scientific process is forced to move from the obvious, the flowing tails of a comet, to the subtle, the faint trace of heat, or the narrow beam of a laser. The final answer may not be a roar, but a quiet, almost imperceptible warmth, a testament to the fact that the most sophisticated technology is often the most discreet. The final window in December is our last chance to put a thermometer on this mystery and find out if it is powered by ice or by design. The search for the unseen, particularly in the realm of infrared and laser signatures, represents the pinnacle of our modern technological reach, an attempt to use the most sophisticated instruments ever created to detect the subtle evidence of advanced engineering. The James Webb Space Telescope, or Webb, is our primary tool here because it is fundamentally a cold telescope, designed to observe in the infrared spectrum, where thermal radiation is most apparent. You should reflect on the significance of a potential infrared anomaly. The basic physics are simple. A technological object, if functioning, must abide by the laws of thermodynamics. Any energy source, whether it is a small radioisotope, thermoelectric generator, or RTG, a microfission reactor, or simply a bank of working electronics, will generate waste heat. If 3I Atlas were merely a passive comet, its temperature would be determined solely by its distance from the Sun and its albedo, or reflectivity. However, if Webb were to detect a temperature profile significantly higher than predicted for a passive object at its current distance, even by just a few degrees Celsius, this would constitute a powerful techno-signature. A higher temperature would imply an internal heat source that is actively driving some process, a signature impossible to explain by natural cometary physics. The quiet wait for the processed, late October infrared data is fraught with this tension, as that was the time when any active thrusters or power systems would have been working overtime during the non-gravitational acceleration phase. The concept of a laser pulse as a communication signature is scientifically sound and represents the most efficient way to transmit data across interstellar distances. For a probe to send data back to its home star, the signal must be tightly focused to prevent dispersion. This requires a beam width of mere nanoradians, meaning the beam is so narrow that it must be perfectly aimed at the receiver. If 3I Atlas is transmitting, we are likely not the intended audience, but rather a tiny, accidental flicker in the side lobe of a powerful interstellar beacon. However, the closest approach on December 19th provides a moment of opportunity. If the probe is programmed to perform a quick data dump before leaving the solar system, perhaps transmitting a wide-field burst to maximize its chances, ground-based optical observatories might be able to detect a powerful, brief flash of light. A coordinated search is necessary, but the difficulty of predicting the exact moment and direction of such a transmission remains the greatest hurdle. This is where the collective human endeavor of optical SETI becomes critical. Unlike radio SETI, which listens, optical SETI watches for brief, powerful, non-solar flashes of light. A laser pulse would appear as a flash that is too fast, too bright, and too specific in its wavelength to be a natural astronomical event. The strategy for December 19th must include coordinating a network of ground-based observatories to watch the probe's trajectory for any such fleeting, microsecond burst. This hunt for the fleeting flicker is the ultimate demonstration of scientific patience, searching billions of star systems for a message that may only last for a single second. The mythic echo here is that of the unseen fire, a small, intelligent flame burning within the cosmic dark, a signal that we must be exquisitely sensitive to perceive. The very difficulty of the detection is, in a way, another layer of techno-signature, suggesting an intelligence that operates with an efficiency far exceeding our noisy, power-hungry broadcast technologies. The silence, you realize, is simply the sound of a highly advanced, covert operation. The search for the infrared anomaly is complicated by the thermal lag of the object. A comet's surface is expected to heat and cool slowly, creating a lag between the amount of solar heating and the surface temperature. If 3I Atlas were an artificial object, its engineers might have designed a thermal control system that actively manages heat, perhaps storing it to power internal systems or radiating it directionally to minimize detection. A simple passive comet model would predict a certain heat curve, and any significant deviation, a sudden, sharp spike in temperature, or a sustained, low-level warmth when the object should be cold, would indicate active thermal management, a clear sign of engineering. The data we are awaiting from the period around October 29th, 2025, is paramount. This was the time of maximum solar heating and, potentially, maximum thruster use, which would have put the greatest stress on the object's thermal control systems. If the data is found to be clean, with no anomalous heat, it only deepens the mystery. It would imply a technological object with an incredibly efficient and stealthy energy system, or a natural object whose thermal properties are unlike anything we have ever recorded. This brings us back to the central theme. The anomalies force us to assume either the existence of physics we do not know, or engineering we cannot replicate. Both possibilities are equally profound, but only one suggests the presence of mind. The quiet act of aiming the world's most sophisticated thermometer at this tiny, fast-moving object is a philosophical statement. We are no longer content to just observe. We are now actively probing for the hidden heat of intelligent intent. As our quiet journey nears its end, we must pause to consider the entire looping narrative of interstellar visitors, from the ambiguous cigar of one Eye Oumuamua to the astonishing X-pattern of 3I Atlas. This is the story of three visitors that has profoundly changed the question of whether we are alone, shifting the discussion from simple probability to the rigorous evaluation of anomalous data. The story begins with the first ambiguity, one Eye Oumuamua. Its non-gravitational acceleration without a visible coma challenged the assumption that all interstellar objects would be rocky or icy remnants. It introduced the possibility of an object of unnatural geometry, perhaps a thin light sail, into the scientific lexicon. Its quick departure and the subsequent lack of definitive data served as a profound warning. Look now, or the answers will be gone forever. The second visitor, 2I Borisov, offered a temporary reassurance. It behaved like a normal comet, with a textbook coma and tail, suggesting that the first visitor was simply an unusual anomaly. But the third visitor, 3I Atlas, has shattered that easy comfort. It has accumulated not one, but 12 profound anomalies, each one requiring an increasingly improbable set of natural circumstances to explain away. This is the core of the looping narrative. The initial ambiguity of the first visitor has been amplified by the profound structural paradox of the third. The current narrative focuses on three crucial, interconnected paradoxes. First, the improbable trajectory, an interstellar object with a retrograde orbit that is perfectly aligned with the planetary ecliptic, whose timing is fine-tuned for a multi-planet flyby, culminating in a seemingly precise, non-gravitational course correction toward Jupiter's Hill radius. The probability of this coincidence is 1 in 20,000. Second, the impossible geometry, a spinning nucleus with a 16.16-hour rotation period, yet producing jets that are tightly collimated and perfectly straight over 1 million kilometers. The visual evidence defies the physics of a rotating, outgassing body. Third, the unseen energetic source, the presence of a sunward anti-tail and non-gravitational acceleration that suggests a mass loss rate and an outflow velocity too high to be easily accounted for by passive solar heating alone. The necessary energy input strains the limits of natural cometary physics. Dr. Loeb's persistent and controversial contribution to this looping narrative is his courage to openly articulate the logical conclusion that the data suggests. He is forcing the scientific community to confront the possibility that the pattern of anomalies is a techno-signature in itself. He is arguing that the alternative that we must accept 12 distinct, statistically improbable natural coincidences is a greater affront to the scientific method than simply considering the possibility of a non-natural origin. The mythic reflection here is the concept of the unfinished tapestry. The universe has given us 3 threads so far, and the third thread, 3I Atlas, is complex, woven with geometric impossibilities and chemical whispers. The pattern is not yet complete, but it is too sophisticated to dismiss as random noise. The quiet tension remains focused on the 22 days between the X-pattern's discovery and the closest approach. This is the final, narrow window for us to get the clean, high-resolution data that will either confirm the comet hypothesis or provide the first irrefutable evidence of a technological visitor. The most valuable data is the velocity of the jets and the resolution of the mini-objects. Where are you listening from tonight? As we stand at this turning point in the scientific history of our species, the core truth of the matter is that we are about to gain more data, and that data, whatever it reveals, will move us closer to understanding. The debate will not end on December 19th, but the foundation for the final answer will be laid. The looping narrative of interstellar visitors will continue, but the chapter on 3i Atlas is about to close, with either a definitive answer or a final, tantalizing ambiguity. The looping narrative of the 3 interstellar visitors has not only provided anomalous data, but has also illuminated a critical human failure: our cognitive inertia. The scientific community has a natural and necessary resistance to changing fundamental beliefs. But the history of science is defined by those moments when the prevailing theory proved insufficient to explain a persistent anomaly. 3i Atlas is the most compelling example of this tension since the discovery of cosmic microwave background radiation, or the inexplicable rotation curves of galaxies that led to the theory of dark matter. In both of those cases, the existing model was sound, but it failed to account for a persistent, quiet contradiction. 3i Atlas is now presenting a similar contradiction, demanding a fundamental reassessment of what an interstellar visitor can be. The analysis of the non-gravitational acceleration perfectly illustrates this cognitive inertia. The acceleration is real. The object is moving off course. The natural explanation is water sublimation, but this explanation requires the object to be losing massive amounts of ice, far more than the observation of an intact nucleus suggests. To compensate, scientists propose increasingly complex natural models, internal pressure chambers of supervolatile ices, or a nucleus composed of exotic, non-standard materials. Dr. Loeb simply points to the alternative: a small, precise push from a technological thruster that makes the non-gravitational acceleration a perfectly natural, intentional event in the context of a mission profile. The cognitive challenge is to accept that the simplest, most elegant explanation for the data is not a comet, but a machine. The simplest explanation, you realize, is often the one that makes us the most uncomfortable. Furthermore, the X pattern and the unsmeared jets present a direct contradiction that cannot be easily resolved with incremental tweaks to the cometry model. The combination of rapid rotation and tight columnation over immense distances demands an active mechanism for stabilization. The geometric precision suggests a degree of control that is inherent in engineering, not in the chaotic, tumbling physics of a melting ice ball. This is the structural techno-signature that is most difficult to deny. The mythic reflection here is the idea of the perfect form. In a universe dominated by entropy and chaos, the appearance of a persistent, organized, geometric structure that defies the local forces of nature has always been a sign of a greater, ordering intelligence. The great scientific challenge now lies in the cross-verification of the 3 key techno-signatures: the kinematic, velocity, the compositional, nickel anomaly, and the structural, mini-objects. A natural comet might display one of these anomalies, but it is highly improbable that it would display all 3 simultaneously. If the final December data shows a high-velocity jet and an unnatural nickel-to-iron ratio and independently moving mini-objects, the evidence becomes overwhelmingly compelling. Dr. Loeb's ultimate gift to the scientific world is not necessarily the discovery of an alien probe, but the creation of a framework for plausible evaluation, a method for asking the most profound question in a scientifically rigorous way. He has prepared humanity for the possibility that the universe is indeed stranger than we can imagine, and that the next great discovery may be hiding in plain sight, disguised as a common, albeit unusual, celestial object. This framework, the Loeb scale, is now a crucial tool, allowing us to move past the initial knee-jerk reaction of denial and into a structured evaluation of the evidence. The looping narrative finds a secondary, deeper echo in the unexpected chemical analysis, the extremely low abundance of water in the coma, a dominant constituent of normal comets, and the relative richness of volatile ices like carbon dioxide and carbon monoxide. While natural comets exist that are poor in water, the combination of water deficiency and the nickel anomaly creates a chemical profile that is statistically unique. Dr. Loeb suggests that this chemical composition may be another layer of the technological camouflage. If the object is artificial, its protective icy mantle would be composed of the most common and available ices in the interstellar medium, which are often richer in carbon-bearing molecules than water. The low water content, therefore, is not a failure of the comet but a design choice by the engineer. This subtle argument that the very chemistry of the coma may be a form of intelligent mimicry raises the intellectual stakes to an extraordinary level. The entire narrative, from the discovery of the cigar-shaped one Oumuamua to the multi-anomaly event of 3I Atlas, argues for the adoption of interstellar object forensics, a new branch of science dedicated to distinguishing between natural cosmic debris and designed technological artifacts. The final few weeks of the object's visibility are the last moments to gather the baseline data for this new forensic science before the ultimate silence descends. We arrive, at last, at the quiet contemplation of the great silence and the unknowable answer. This final reflection is not about the data we have, but the humility required to accept the answer, whatever it may be, and the profound silence that will settle once 3I Atlas is gone. You must understand the two possible conclusions and their consequences for our human sense of place. If the final data from the December 19th closest approach the spectra, the images, the velocity measurements confirms the natural hypothesis, we will have learned that interstellar comets can be far more active, complex, and structurally resilient than our solar system models had ever predicted. The 12 anomalies will be explained, albeit with a series of highly specific, exotic natural circumstances, supervolatile ices, non-standard material compositions, and highly complex, layered structures. This is a valuable, profound discovery that expands our understanding of cosmic diversity. We will have closed the book on the artificial hypothesis, proving that even the most extraordinary claims can be explained by nature, and that the universe is just that strange. If the final data from the closest approach reveals an artificial hypothesis, we will have crossed a profound philosophical Rubicon. The detection of thruster speed jets, non-gravitational trajectory corrections by mini-objects, or irrefutable chemical technosignatures will mean we are not alone. This discovery would fundamentally change everything: our priorities, our cultural narratives, and our sense of cosmic significance. It would confirm that another intelligence is out there, capable of sending emissaries across the light years to study us. The immediate consequence of a definitive technosignature would not be a dramatic announcement, but a period of intense, cautious, internal analysis. The bar for making the public announcement would be extremely high, requiring multiple, independent confirmations to rule out any possible mistake. There would be a period of quiet, closed-door debate among scientists between the collection of the data and the final, peer-reviewed conclusion. This is the final, most dangerous gap, where the public, left wondering, would be most susceptible to speculation. Dr. Loeb's philosophy urges radical transparency during this gap. He argues that the data should be released immediately, allowing the global scientific community to debate it openly, rather than feeding the suspicion that something is being concealed. This openness, despite the noise it creates, is the surest path to maintaining public trust. The mythic reflection here is the concept of the revelation. The universe is a powerful revealer, and our job as scientists and as curious humans is to simply observe the evidence and follow where it leads, even if it leads somewhere we are not ready to go. The alternative intellectual cowardice, closing our eyes to the anomalies, is worse than any uncomfortable truth. As 3I Atlas moves toward its inevitable exit from the solar system, we must prepare for the final, unknowable answer. We may not get a definitive, 100% certainty answer in the immediate aftermath of December 19th. We will get data, numbers, spectra, and images that will allow us to calculate probabilities with greater confidence. The final answer may only emerge years later, after the papers are published and the conclusions are accepted. Yet, the object has already taught us a profound lesson. It has taught us that the universe is full of surprises, that our models are incomplete, and that the search for truth requires a humble, open mind. The incompleteness is not a failure. It is an opportunity to learn, to grow, and to become better at reading the subtle messages the cosmos is sending us. We arrive, at last, at the quiet contemplation of the great silence and the unknowable answer. This final reflection is not about the data we have, but the humility required to accept the answer, whatever it may be, and the profound silence that will settle once 3I Atlas is gone. You must understand the two possible conclusions and their consequences for our human sense of place. If the final data from the December 19th closest approach the spectra, the images, the velocity measurements, confirms the natural hypothesis, we will have learned that interstellar comets can be far more active, complex, and structurally resilient than our solar system models had ever predicted. The 12 anomalies will be explained, albeit with a series of highly specific, exotic natural circumstances, super volatile ices, non-standard material compositions, and highly complex, layered structures. This is a valuable, profound discovery that expands our understanding of cosmic diversity. We will have closed the book on the artificial hypothesis, proving that even the most extraordinary claims can be explained by nature, and that the universe is just that strange. If the final data from the closest approach reveals an artificial hypothesis, we will have crossed a profound philosophical Rubicon. The detection of thruster speed jets, non-gravitational trajectory corrections by mini-objects, or irrefutable chemical technosignatures will mean we are not alone. This discovery would fundamentally change everything: our priorities, our cultural narratives, and our sense of cosmic significance. It would confirm that another intelligence is out there, capable of sending emissaries across the light years to study us. The immediate consequence of a definitive techno-signature would not be a dramatic announcement, but a period of intense, cautious, internal analysis. The bar for making the public announcement would be extremely high, requiring multiple, independent confirmations to rule out any possible mistake. There would be a gap, a period of quiet, closed-door debate among scientists between the collection of the data and the final, peer-reviewed conclusion. This is the final, most dangerous gap, where the public, left wondering, would be most susceptible to speculation. Dr. Loeb's philosophy urges radical transparency during this gap. He argues that the data should be released immediately, allowing the global scientific community to debate it openly, rather than feeding the suspicion that something is being concealed. This openness, despite the noise it creates, is the surest path to maintaining public trust. The mythic reflection here is the concept of the revelation. The universe is a powerful revealer, and our job as scientists and as curious humans is to simply observe the evidence and follow where it leads, even if it leads somewhere we are not ready to go. The alternative intellectual cowardice, closing our eyes to the anomalies, is worse than any uncomfortable truth. As 3I Atlas moves toward its inevitable exit from the solar system, we must prepare for the final, unknowable answer. We may not get a definitive, 100% certainty answer in the immediate aftermath of December 19th. We will get data, numbers, spectra, and images that will allow us to calculate probabilities with greater confidence. The final answer may only emerge years later, after the papers are published and the conclusions are accepted. Yet, the object has already taught us a profound lesson. It has taught us that the universe is full of surprises, that our models are incomplete, and that the search for truth requires a humble, open mind. The incompleteness is not a failure. It is an opportunity to learn, to grow, and to become better at reading the subtle messages the cosmos is sending us. The clock is ticking toward December 19th. We have done all we can do. We have prepared our instruments, we have laid out the anomalies, and we have asked the essential questions. The rest, the final truth, lies within the light of the most peculiar, most fast-moving object ever to pass through our silent neighborhood. The quiet triumph of the 3I Atlas encounter is that it has irrevocably changed the landscape of the search for extraterrestrial intelligence. Regardless of the final classification, the event has established a new protocol for anomaly investigation, mandating that any future interstellar object must be subjected to immediate, high-priority, multispectral analysis. We have learned to mobilize faster, to question more deeply, and to be more transparent in our findings. The greatest irony is that the resistance faced by Dr. Loeb has ultimately led to a stronger, more rigorous, and more open scientific process. The long-term consequence of the ambiguity will be the funding of dedicated interstellar object interception missions, spacecraft designed to rendezvous with future visitors, a mission profile that was once considered pure science fiction, but is now a concrete, 21st century engineering goal. The object's departure is therefore not a final goodbye, but a catalyst for the next, more ambitious phase of human exploration, a testament to the persistent power of curiosity. The ultimate silence of the departing object will be filled not by despair, but by the quiet hum of mission control rooms planning the capture of the next interstellar messenger. The quest for cosmic company has moved from passive listening to active, forensic hunting, and that is the most profound legacy of 3I Atlas. We may already be part of the experiment. The clock is ticking toward December 19th. We have done all we can do. We have prepared our instruments, we have laid out the anomalies, and we have asked the essential questions. The rest, the final truth, lies within the light of the most peculiar, most fast-moving object ever to pass through our silent neighborhood. And so, we bring our quiet cosmic journey to a close, a fleeting moment of observation in the immense, enduring silence of the universe. We tracked a ghost from interstellar space, measured its improbable path, and debated its silent purpose. Whether comet or probe, 3I Atlas has served as a profound mirror, reflecting both our ingenuity and our institutional caution. The final data is coming. The truth is imminent. History bends, but never breaks. The universe is always sending us messages, and our highest honor is simply to be ready to listen, rest well, and sleep in the knowledge that your curiosity is the engine of all cosmic wonder.